Why don't we call our meeting to order then? And my goodness, well, I think that yesterday's events underscore just how extraordinarily important and impactful the work in California is, and frankly, the work of this committee in showing positive, effective, practical ways we can address climate change in a manner that is both economically productive as well as extremely effective from a climate adaptation perspective and meeting our biodiversity goals. It's the proverbial win-win-win-win-win that I hope can continue to set a model of positive direction, not just here in California, but beyond. So these are really interesting times for our work. And I want to just take a minute to thank everybody on the committee as well as within the administration for all the work that you've done on this endeavor. This is our last meeting. It doesn't mean necessarily that it's the end of our work, as we may want to, in our closing business conversation, talk about any final steps that we want to take following the third item on the agenda. But I just wanted to take a minute to say thank you all. And I think that this is very impactful and it will outlast our current national political situation, which for climate change. So with that, are there any announcements from the CNRA or ARB staff?
Just also to reiterate our thanks for everybody. This has been 2 years coming together, and that we really appreciate all of the work again. And I'll probably say this also at the end. So, but anyway, we'll just start out on that note. So thanks.
It's good to start and end with appreciation and positivity. So
there you go.
Thank you, Adam. Well, then why don't we go to roll call, and we'll start just alphabetically as it's here listed. Christy. Christy was having some external appointments and she might not be able to be on with us until potentially later. So, John.
I am here, remote. Thank you, Lori, for leading us so effectively, and to all the staff as well.
This has been a wonderful first step for our work. Nathaniel. In other situations, we would assign him to lunch duty. Matt. William?
Say William?
Yeah.
Yep, I'm here. Thank you, Lara, for being such a wonderful leader and the staff as well.
Hey, one of the most amazing things that I think we learned in this was about salmon and rice fields. So we're looking for more from you. Lara?
It's happening.
Is Lara with us?
Yeah, I'm here. And yes, thank you, Lori, and everyone. And I just want to note that I have to leave at 4 o'clock today if we're still going. Apologies for that.
Okay. Connor? Debbie?
I'm here, and I just wanted to note that John pointed out that chaparral is spelled wrong on the first slide, so just sharing that. But yes, I'm here.
Mark?
Yep, I'm here.
Wonderful. Carrie?
I'm here. I also have to look up chaparral every time.
That's very not straight.
All right, Melissa?
I'm here.
I think I'm here. And Marian?
I'm here, and I'd like to pile on with the gratitude for your leadership, Lori. And then I'd also, I will have to leave by 4:15 today as well.
Okay, well, if we decide we're going to do one last hurrah out of this, I think that Marian and Lara are going to have leading roles because they will not be able to object. Very good.
I'll take it. I'll take it.
Very good. All right. Well, having completed the roll call, can we move to our next slide? And yeah, I mean, it really is terrific. And I just want to underscore our appreciation to you, Debbie, for having arranged this in bringing in 3 such wonderful speakers. And in fact, I'm going to turn over to you, Debbie, to run through their presentations and to guide the conversation. And I'll step in as needed at the end. But this is really impressive. And I just want to thank Yufang, John, and Max enormously for being with us today. So, Debbie?
Thank you, Lori. I wasn't expecting that, so I'll do the best that I can. So yeah, we have 3 wonderful speakers today. Yufang Jin from UC Davis, John Killey from the USGS and UCLA, and Max Moritz from UC Santa Barbara, and also part of UC Cooperative Extension. And so we'll start with Yufang, and she's going to talk about some of the grassland modeling that she's been doing over the past several years across the state. Yufang, do you want to go ahead? Yep. Okay, perfect.
Oh, okay. You got my slides. All right. Thanks so much. Yeah, it's nice to see a couple of familiar faces and names on the committee. So today I'm gonna share with you some of our recent work on monitoring and modeling the production of annual grassland in California. Can you hear me okay? Just want to check before I go ahead.
Yes.
Yes.
All right, perfect. So yeah, I think we can advance to next slide, please. So California's rangelands actually covers about 4 to 6 million acres. It supports almost 70% of state's livestock forage base and generating about $3 billion in cattle and sheep industry per year. And I look at NASS data, we actually had about 14,000 ranches or farms working in this industry. So it's a very diverse landscape in terms of production, both across space and across multiple years. To understand the forage production in California's annual grasslands, let's first look at the typical growth cycle. Next slide, please. So as most of us are pretty familiar, we have a very unique Mediterranean climate. The annual grasses typically germinate like in late fall when we get initial rainfall. If weather is not too cold, they'll start to germinate, and then it'll grow very rapidly as temperature warms up and there's more sunlight as season goes. If we have enough rainfall, and pretty much around March or April, toward the end of growing season, if the soil moisture is completely depleted, it'll start to like a senesce. So then there's not much production afterwards. So the production of annual grasslands is really dynamically linked with quite a few seasonal weather patterns. So it's relatively complicated. We have both seasonal variation of precipitation, which is out of sync with seasonal patterns of temperature and also sunlight. Next slide, please. So as I mentioned, the California landscape is very diverse, mostly due to the differences in long-term climate. On the left, I'm showing you precipitation can vary from below 160 millimeter per year all the way to above 2,000 millimeter per year in the northern part of the states and Sierra Nevada. And if we look at the production, even within like a very short distance, for example, in San Luis Obispo County, the observed forage production can vary dramatically from the coastal side in 2006, which is a relatively wet year. We can get as much as more than 10,000 pounds per acre. And a little bit further away on the east side of San Luis Obispo County inland, we got only like 4,000 pounds acre. So there's a huge spatial heterogeneity. Also, it fluctuates dramatically from year to year, right? In dry years, for example, in 2014, the coastal size production dropped to 3,000 pounds per acre, and the inland side is even like less productive. So this like a large fluctuation in terms of forage production and also like a large spatial variability really pose a lot of challenges for range management. So the question we are trying to answer is how do changes in climate or weather patterns affect annual grassland production, and how this impacts may be different across different ecoregions. Next slide, please. So in order to answer these questions, we really need to get a large long-term data record for forage production across the whole California's rangeland. We developed a satellite-based approach to monitor the grassland production almost at daily timescale by using satellite observations from different sensors, Sentinel, Landsat, MODIS. So we can get to almost a daily observation record, and in the middle, the time series shows the vegetation index captured by these remote sensing systems at almost at daily time scale. You can see very like a pronounced seasonal cycle, and also there's large year-to-year variability. So this is pretty much to track the plant growth across every single pixel, grassland pixels. So we used a semi-empirical light use approach to converting the satellite observations to how much light the plant is absorbing, and then converting to biomass. So we did use lots of ground observed data. We are partnering with county advisors across the state. We have more than 30 counties involved, collecting monthly clipping data across very diverse grassland. We calibrate the model with all this on the ground measurements, and the bottom panel shows our estimated forage production at monthly timescale agreed pretty well with clipping data. So we are pretty confident this estimation tool. So we generate the forage production at daily timescale and then aggregate it to annual timescale. On the next slide, you can see the state level forage production distribution at annual time scale from 2004 to 2017. This is a product derived from a fusion of MODIS and Landsat at 30-meter resolution. On the right, I'm also showing you the monthly precipitation distribution for each individual year. As you can see, there's a large year-to-year variability. Right now, 27 is a relatively dry year. The production is pretty low across the board, and also in another prolonged drought, 2012 to 2016, we also estimated a huge reduction in terms of forest grassland production. And 2017, we can see that clear recovery after the rainfall picks up. Next slide. So with this long-term data record at 30-meter resolution across all grassland pixels, we built a machine learning model trying to understand what are the factors that determine both the spatial variability of forage production across the state, and also what are the main factors affecting the year-to-year variability in terms of forage production. We pulled out all the climate data from DayMat, which is a daily graded weather data. and also the topography soils information, because topography soils affect lots of local site conditions, including the moisture conditions, besides the larger scale climate patterns. Next slide, please. So first, let's look at the spatial variability of forage production. So we derived the long-term mean forage production for each 30-meter pure grass pixels, shown on the left. As you can see, the mean production is around 2,900 kilogram per hectare per year, but the southern central coast is much less productive. There are about maybe around 10% of areas which actually has more than 4,000 kilogram per hectare per year. So what's really driving this large variation spatially in terms of long-term mean production? We used gradient boosting tree regression machine learning models to simulate the impact of long-term mean seasonal weather variables and soils topography variables on the long-term mean production. So what we found is the total precipitation amount during the growing season is the most important factor determining the spatial patterns, which is expected. And the precipitation distribution across different months also played an important role. Additionally, the minimum air temperature is also explaining more variability besides precipitation. The topographical variables and soil properties pretty much only modulate the local spatial variability in forage production. Next slide. So with the trend machine learning models, we were able to look at the marginalized impacts of each one of those factors on the spatial variability. So this plot pretty much showing if anything else was held constant, what's the response of forage production to each one of the single variables. So I just wanted to point it out, for example, for precipitation distribution across different months, what we found is for areas where we had relatively uniform precipitation across growing seasons, that's where we saw relatively higher production. In terms of a minimum air temperature during growing season, the areas which is warmer in terms of minimum temperature actually are more productive. In contrast, if you look at growing season mean temperature, those regions much warmer actually had low production. So this is just like piecing together all the potential variables in affecting spatial patterns of forage production. Next slide, please. So yeah, if we going back to the impact of total amount of precipitation during growing season, because that's still the most important factor as expected. If we just look at long-term mean production during the dry years, we saw like almost 33% departure from the long-term mean, like a reduction of production. But that reduction is not uniform across the landscape. For example, the drier areas, as you see on the left side, central coastal regions, we actually, especially on the east side, some areas can experience more than 50% of forage production. So, so this like analysis or the map gave us some insights that the drought vulnerability for our annual grassland is very region specific. Next. So yeah, so next we want to look at what are the impact of climate on internal variability of forage production. As we can see from the map, there's a huge fluctuation in terms of forage production. More or less, it's in par with a total amount of precipitation change from year to year, but there are also many other weather variables at different seasons that can moderate this response of production to climate. Next slide, please. So yeah, again, we used this long-term data record of annual forage production and bringing together all the weather information, both monthly precipitation temperature and also seasonal precip temperature, together with some long-term mean production, because that's really capturing more like a local topography and soil impact on the forage production. So we built machine learning models trying to predict the annual forage production at every individual ecoregions. We did try statewide models, but at the end, we found the region-specific models can capture better the year-to-year fluctuation in terms of forage production. Again, if you look at the feature importance, the precipitation amount during the growing season is still the #1 important factors regulating year-to-year variability for forage production, and the precipitation distribution across months is also important, which is pretty similar with the findings from our determinants for spatial patterns. Again, temperature, both minimum and mean temperature, maximum temperature also played important roles. Next slide, please. So here I'm just showing you the temporal sensitivity of forage production to weather variables, because we built separate models for each eco sections. Actually, we have a total of 23 eco subsections. The number on each graph is showing you how many subsections that particular variable showed up as like top 7 important factors. What we can see from here is the precipitation distribution, like how evenly precipitation is distributed across growing season is actually most important in terms of forage production fluctuation. So usually more uniform distributed precipitation will enhance forage production for most of these sub-ecoregions. And I also wanted to point out the minimum air temperature, almost half of the subsections, we did see the enhancing production by the warmer minimum air temperature. In contrast, if we look at the mean air temperature, we saw negative impact. That means the hotter years during growing season, the mean temperature actually will reduce the forage production. So this is more like looking at interannual variability of forage production, how they are affected by weather variables. Next slide, please. So with this model, we did a projection of future forage production using projected future climate change under RCP 4.5 scenarios. We only picked 4 climate models, downscaled future climate variables. So this, yeah, I think it's 1 kilometer downscaled climate variables. So the projected forage production, if you look at the average over the all annual grasslands, we only saw like a very small reduction in terms of annual grassland. However, if you zoom in, look at any particular regions, we'll see almost about 60% of areas, we did see some reduction in forage production by the end of century, although the magnitude is not like huge. but also 40% of areas we did see increase of forage production, mostly in the drier areas. So those two changes in two different areas actually counter each other. So at the average statewide, we didn't see significant change in terms of forage production by the end of century. So we also look at the contribution of each individual weather variable change to the forage production projection by the end of century. Next slide. So yeah, typically in drier areas, so the plot is arranged from the drier sub-ecoregions to wetter sub-ecoregions from left to right, and drier areas, we did see some increase of annual grassland production, especially in central coast regions, mostly driven by like a precipitation, total amount of precipitation increase, and also the warming in minimum temperature. So as we explained earlier on, the impact of those variables. At the other part of the state's weather ecoregions, North Coast and Sierra Nevada foothills, we did see some reduction in production, mostly driven by the temperature, warmer temperature, and in the more moderate precipitation areas, we also see moderate reduction in terms of forage production, mostly driven by the change in precipitation distribution across the growing seasons. So yeah, this is just showing, although we didn't see the significant reduction in forage production under projected climate change, we did see at the regional scale, there is a significant change for the management or adaptation perspective. I think we do need to consider like a local conditions and local responses in developing those strategies. Next. So this, all these studies is really looking at interannual variability. So it's more like a short-term response of grassland to climate change. But we all know the impact of climate on vegetation, or in particular on grassland, operated at different time scales. At shorter time scales, like decades or even 20 years, it's a lot of like a response from physiology or leaf areas. So those are the rapid response. But if you zoom out to look at a couple of decades, in the longer term, we would expect the impact of species composition or population density. Those will be gradual change from like a climate variability. So one of our early studies actually looking at the differences between this short-term versus long-term effects of change in precipitation. What we found is was also based on a large data set from remote sensing record. What we found is at longer time scale, the response is actually amplified fivefold compared to more short-term like a response to precipitation. So so when we think about impact of climate change, we do need to put that in the context. Are we looking at more shorter-term response, or are we looking at a more longer-term response through different mechanisms? So yeah, I think with that, I'll just like conclude with a couple of points. Next slide, please. So yeah, so we developed this locally calibrated, co-designed and developed with a large network of county advisors to better estimate the production of California's annual rangelands, which can provide many data-driven information for ranching management and also for developing climate adaptation strategies. Yeah, I also wanted to emphasize the regional differences in production vulnerability to climate. So because there are multiple counteracting effects of seasonal temperature, if you look at minimum temperature or maximum temperature at different seasons, they may give you, may result in different impacts. So yeah, hopefully I think with all this monitoring and also large data driven models, we can have a better understanding and also have better science-based guidance for future grassland management. So yeah, with that, I'll just stop there. I'm happy to answer any questions you may have.
Debbie, do you want to call on people for questions, or would you like me to?
Would you mind doing that? I'll just say thank you, Yifang. And I was one of those locally calibrated people. I was out.
Oh
there
yeah, I was
collecting
going
data.
to mention your name, but
I don't think we've met in person yet, but
No.
anyway,
yeah,
nice to meet you and thank you for giving the talk. And Lori, if you want to take questions, please.
Well, thank you very, very much. I want to note that Matt Holmes did arrive in the meeting, so we should record him as present. And Matt, you had a question. Did you put it in the chat? Do you want to say it?
Yeah, I put it in the chat because I wasn't sure if we had time for it. But I was just surprised to hear at the in the 23 regions we weren't seeing significant reductions in forage production. When in my region we're watching forage land disappear for irrigation for grapevines, and so I wasn't sure if the study was able to look at that management or that adaptation decision to pour water on forage lands for grapevines. And then also, I wanted to know how this heat is being integrated. Is this general National Weather Service heat, or are we using any of the new granular extreme heat data? Because it's one thing for it to be a warmer year. It's another thing for it to be scalding hot at the peak of spring or during mid-production. So I wasn't sure if there's any new ways that we can understand heat, especially considering Jet Propulsion Labs' new high tests, aerial and satellite observations. But fascinating. Thank you.
Okay. Yeah, thank you. Those are great questions. So in terms of the impact of management on forage production, we thought about that questions actually for quite a while, because we know California rangeland is mostly grazed landscape, right? So for this study, we didn't separate the impact of grazing from weather or local topography or soil properties, because we couldn't get access to all the grazing records. So that's one of the limitations for our studies. So I would say for the modeling perspective, we made a kind of assumption, like assuming there was not much like significant larger scale change in terms of management practices through time. So, but that's interesting questions. We need to investigate down the road the management, both either irrigation or grazing. Definitely gonna have.
Yeah, I think it's something to look at, because there's a crowd of guys, they got all the water and they get to do whatever they want with it. And so science and math and weather don't really matter to them. And so they'll decide to irrigate or not irrigate, regardless of the climate-driven impacts that the rest of us are suffering from. So there's a reason why you don't have that data set.
Yeah. Okay. For the second question, in terms of the extreme heat waves, those weather events, we didn't specifically isolate the impact of those extreme events on the forage production. The input for our model is all we started from daily, like a DayMat, daily weather variables, and then aggregated to monthly time scale. So we do have like a minimum, mean, and maximum air temperatures at monthly and seasonal time scale, but we didn't like quantify the extreme heat events, right? So I think that would be another like science questions that would be very interested to explore because we can quantify all those extreme weather events using the daily weather data and then look at the impacts on the forage production, right? So for now, the model we built didn't take account of those like individual events for simulation of forage production. But it's
thanks, Yufeng. I put in the chat the Jet Propulsion Lab high test extreme heat sensor data, which is coming in at sub-meter. And I think right now the challenges are the number of flyovers or, you know, the intervals of the data. But certainly a really hot, crispy day changes everything for the ecology.
Yes, yeah. The thermal sensor is extremely helpful, especially at that resolution.
Are there other committee questions from the room before I?
Mark.
You find Mark. This is Mark Schwartz. Thanks for the presentation. Hi. I was wondering if I didn't notice anything in here, but I was wondering if you could speak to the issue of carryover effects from drought. Like I don't expect it to be strong, but did you analyze for them, and do you have anything to say about them?
Oh yeah. So that's a very good point. Yeah, we didn't investigate the carryover or legacy impact of preceding precipitation or even heat waves on next year's production, right? So that's one thing we are currently developing with the Western SARE grant. We are actually looking at the forecasting using all the sequential weather variables. So we can look at like a cumulative precipitation, for example, from previous 2 years. From one of my Southern California studies, we actually found that carryover impact. If you have 2 super wet years, you definitely will get higher production even for next year. But yeah, it's not like a super clear, the message. We also suspected, especially on ungrazed land, if you have very productive years and with all the dead grasses on the ground, it may actually like reduce the production for the next year. So yeah, I think for the drought impact, yeah, maybe I think one mechanism I can think of is maybe through the seed bank that can have carryover impact if you have a prolonged drought, and then if you have reduced seed bank, that can affect next couple of years production. So that's a very good point. And then there's a potential we can explore all this carryover impacts using nowadays there's a very advanced machine learning tools like a long short-term memory, looking at sequential data on like next year's or next season's production. I think that's one area we are trying to develop, not just for understanding the carryover effects, but also for forecasting, like forage production purpose.
Thank you.
Yeah, thanks.
We'll go to John, and then I'll ask a couple of questions. I don't think there are any other committee questions. I'm going to ask that we hold public questions until the end so that each of our guest speakers can have the full time to put forward their presentations and answer committee questions. So members of the public, please hold on to your questions for a little bit longer if you don't mind. John?
Thank you for the presentation.
Are you going to bring up the presentation, or should I share screen?
Oh, I'm sorry. I meant John Calloway.
Oh, I'm sorry.
So John Calloway is a committee member, and then I have just a couple questions, and then we'll come to you, John Keeley. Apologies.
Okay, thanks, Lori. And thank you for the presentation. That was really informative. I was wondering, it looks, so you focused primarily on above ground productivity, I'm assuming. I wonder if,
Yeah.
since so much of the carbon issues are below ground, have you looked at, how above ground productivity and below ground productivity might vary along with the variables you looked at with precipitation or temperature or regional issues? Have you looked at, or have others looked at that also that would be valuable for us to know about?
Yeah, unfortunately we haven't looked at the below ground productivity, right? Because for remote sensing observations, what we as the sensors are measuring is all the reflected energy from plants right above ground. So that's what we are trying to estimate in is all above ground. For below ground, I haven't seen direct estimation from remote sensing. There are some other approach which you can couple process-based models driven by satellite observations. So there's process-based how carbon is allocated above ground and roots underground, right? So yeah, I think a direct estimation of below ground, it's gonna be super hard with remote sensing observations, but there is potential coupling process-based models with remote sensing observations.
Lori, we have a couple more questions here in the room from committee members, I think.
So,
Okay, let's go to the room then. And let's try to keep this to till 1:50, and then let's switch over to John Keeley. I want to make sure that we have appropriate time so I can hold my questions as need be. So who in the room has another question?
I guess Will. Great talking, Pang. It's been a while since I worked in grasslands, but it was our observation that in about mid-February, the total nitrogen content of the grasses predicted yield and at the end of the season. And so do you have any sensors that pick up greenness or estimate the amount of nitrogen?
Okay.
Would be another way to cross-validate your.
Yeah, that's a very good point. So the nitrogen content monitoring is relatively trickier. So if you look at the literature, most of the nitrogen estimation is actually using the correlation between nitrogen and chlorophyll, because chlorophyll absorption is something that we can more or less directly measure with satellite sensors, because we have a wavelength region in the red and another one in the blue region. Those are the wavelength regions that plants absorb very strongly for photosynthesis purposes. So those also related to greenness we can observe with most of our optical sensors. The nitrogen content, because it's biochemical, it has its own absorption features. Usually those absorption features are located in the mid shortwave infrared regions, so like beyond 1.5 or 2 micron. So some sensors do have those maybe 1 or 2 channels, but it's relatively broad wavelength regions. It's relatively hard to quantify the concentration of nitrogen. The newer sensors, like emerging hyperspectral sensors, do have narrow, very like a fine spectral resolution, and they have more than 200 wavelength bands. Those we can use to capture the nitrogen absorption of energy, so we can do better estimation of nitrogen content. So we do have a European Prisma hyperspectral sensor, and JPL is developing newer generation hyperspectral sensors, SPG. So in the future, we will have capacity to estimate nitrogen content of plants. And then, as you mentioned, the mid-February nitrogen content is a very good indicator for end of season production. So with that information, I think we can do better, more near real time forecasting with all the observations, both for like a greenness and also the nitrogen. Yeah, that's very good point, idea to explore.
Let's have one last question. Let's save the rest till afterwards. So if you have other questions for Yufeng, perhaps you can stay with us until the end of all the presentations, Yufeng, so that other
Okay,
questions
sure.
could get asked at that time. That would be great. Is
Sure.
there one other short question in the room before we move to John Keeley?
I saw you raise your hand. I do, but it's, I don't know if it's till the end. No, I think we're good, Lori.
Okay, then I'm going to save my questions for later and ask that we move over to you, John, so that we can hear from you. Thank you.
Thank you, Lori. Are you going to put my slides up or should we share screens?
You can share screen, John.
Okay. Okay, are you seeing my screen?
Nope.
Then apparently I don't know how to share screens.
Well, is it possible for you to share it from the room, Chelsea?
Yes. I
Found that
can.
might just be easier to, then we know we've got it.
Yes, I just need to pull it up.
Okay. Well, Yufeng, while she is pulling that up, let me ask you a quick question then. It sounds like while the remote sensing is really become fine-grained data for acknowledging what current conditions are there the algorithms to translate that to net carbon storage? It's clear that we don't have those for the below ground, but do we have it for the above ground? And so I'm going to tie that question later on.
Yes.
So is this my screen now or is this yours?
This is, I think, from Chelsea.
That's right.
So this
Okay.
is, Chelsea's running this.
And I assume since I'm not sharing my screen, you can't see my pointer?
That is correct.
Okay. Well, thank you, Lori, for the invitation to participate. And Debbie, thanks for the logistics support. I appreciate that. As you can tell from me jumping in front of John Calloway, I'm very anxious to participate in this. And what I would like to do just very briefly today is just touch on what I think are some current issues in chaparral fires and how they contrast with fires in other parts of the state. Go ahead, next. There's one way of approaching how Southern California chaparral might relate to other regions of the state is to focus on what are some of the important factors driving fire regime. And four that I think are probably the most important is the fuel condition, typically moisture, the fuel load, and we need to separate out herbaceous from woody fuel loads because they have very different ultimate causal factors, extreme winds and ignitions. I'm going to start just by trying to illustrate fuel moisture differences across the state and how they relate to fire. Go ahead, next. This is some work that we currently have under review where we're looking at just this one proximal factor, which is fuel moisture. And fuel moisture is typically measured when we're thinking about fire as vapor pressure deficit. And what we see here on the left, those panels represent CAL FIRE landscapes in the North Coast, North Interior, Sierra Nevada, Central Coast, and the South Coast. And as you can see, not surprisingly, the vapor pressure deficit varies through the seasons. Winter is almost always, or always, the lowest vapor pressure deficit. Summer is typically the highest. But the one point that I want to make out of this slide is if we compare different ecoregions, for example, the North Interior dominated on Forest Service lands, dominated by forests, we see a highly significant relationship between vapor pressure deficit in the summer and the amount of area burned in a given year. So each of those spots represents a different year, and we see that years that have very high vapor pressure deficit in these forested landscapes have higher area burn, illustrating that climate is certainly driving fires in this part of the world. If we contrast that, say, with the South Coast, and particular South Coast Cal Fire landscape, which is much of it dominated by chaparral, we don't see any relationship between vapor pressure deficit and area burn, suggesting that the amount of aridity and the climate in particular is going to have a different role in different parts of the state, and it's probably the least important in Southern California chaparral. Go ahead, next.
Wait, question. What are
Yeah.
the colors on your graph? Are those all the same
Okay, the
size?
blue is winter. Sorry, I didn't explain that.
Okay.
Blue is winter, green is spring, orange is autumn, and red is summer.
Okay, just so you know, like it's very challenging to see because of the size, it's to see the labels and stuff like that.
No, I
So-
understand. No, my mistake. I should have explained
no.
the color patterns, but and it's not surprising. You expect summer vapor pressure deficits, the ones in red, to be the highest, and you expect winter to be the lowest. But the important point that I want to make here is just focusing on summer vapor pressure deficit in forested lands in the North Interior, highly significant relationship with area burned. South Coast, primarily chaparral dominated, we see no relationship with the vapor pressure deficit, suggesting climate is playing a bigger role in fires in some parts of the state, particularly in forests, and less of a role in shrublands. Go ahead, next. Next slide.
We're seeing a next slide.
Oh,
This is table
well,
one.
I'm not there. That's the one, table one.
Yeah, table one is now
one of-
up.
One of the things that we've looked at in comparing these 5 different regions is the regression analysis of area burned in a given year versus primarily climate parameters. And since the records go back to 1910 for Forest Service lands, where we've broken it out into early period and the later period, being 1970 to 2021. And I don't want to go through each of these regression models. I just want to bring up one point which illustrates something I think important about fires in our landscape, and it relates very closely to what Yufeng was talking about. And that is, there are a number of areas in yellow there that in all of the different regions that suggest a very different relationship between vapor pressure deficit and area burn. For example, Cal Fire landscape in the North Coast at the very top, low summer aridity in the last 50 years is associated with higher.
We may have lost John here for a minute. Chelsea or Clessy, are you having the same issue that John is frozen?
Yeah.
Okay. Why don't we give him a second to see if he comes back on, and perhaps we can go back to a key question for Yufeng, if that's all right then.
Sure.
So a key question I wanted to ask you, you were flagging that there are compositional issues that you are able to discern with these patterns. And so that has significant impact on biodiversity. Most of these grasslands, I'm assuming, are dominated by European grasses. Is that correct?
I would guess so. I know
Yes.
I don't know the exact names, but Forbes and yeah, different type
Yeah.
of process.
So the reason for my question here is, as you are looking at this out through 2100 in your modeling, and you discern such interesting regional finer grain differentiation, could this be a tool for the kind of conservation planning for biodiversity support of key species in this kind of grasslands composition? And B, can we then also link that to two things: stress tolerance for drought, which I imagine natives are somewhat more stress tolerant, fire tolerance, and total sequestration. So from the point of view of being able to use your remote sensing and analysis and model approach, could this be a decision support tool, for example, for the state as we look to implement some of the targets that were identified in the governor's announcement back this Earth Day? So I realize that's somewhat complicated, but the linkage here is the remote sensing, how we can utilize this within your modeling and projections to target key areas for biodiversity conservation as well as carbon sequestration enhancement, and therefore conservation activity or land use planning.
Okay. Yeah. So remote sensing can be very useful tool to like estimate both above ground biomass and also to detect or estimate the fraction of species coverage, right? So that's one, on the species level, that's one thing we haven't started to investigate yet. But for our like a clipping data point sample size that we are part of the network, besides the clipping data biomass, we are also collecting the species composition data. So hopefully, with enough training data, we can develop algorithms to basically map or estimate the fraction of each individual species, which is more challenging. But given enough training data and bringing multiple remote sensing observations from different sensors at different scales, it's possible to generate that monitoring tool, and we can always go back in time. Similarly, we can derive maps of different species composition and then build a model to link that with all the sequential weather, climate data, and also topography, soil properties, right? And then once we build that empirical model, and then we can project to the future and identifying which areas are more vulnerable for certain species, and also understanding the vulnerability of each individual species, how they respond to drought. Yeah, I think it's possible, but it does take more efforts to develop that model, because we need lots of training data. That species level data is really hard to get. Yeah, I think it's just taking more resources to develop the model and then predict. But it's totally doable given enough observational data to train the model. Yeah.
And do you have carbon sequestration algorithms by species so that you can associate total carbon stock by grass species? I'm just not aware, so
yeah, we don't have that models yet. I think usually when we do remote sensing based net carbon storage or carbon fluxes, there are two like broad category approaches. One is, as I mentioned, there's a process-based models, right? That can be simulating individual species, but it's not pure process-based models. There's one developed by Jim Randerson and other folks early on. It was actually used by Mike Golden and the group. So that one is taking remote sensing observations and then derive GPP and then using all the other process to allocate to different pools, right? And then there's also respiration that's simulated in the model. So that's more like a coupled remote sensing and process models that can get to the estimate of different carbon components. Another approach is more empirical. There's quite a few studies trying to take advantage of FluxNet, eddy covariance tower measurements, like Ameriflex, and then European has their Flex Tower. By using all those high frequency, super accurate measurements of carbon fluxes, link that with a lot of predictors, right? So remote sensing can capture like a plant growth dynamics, and then also weather data, like a huge predictors, and then just build that model, because we nowadays we do have a relatively decent large network of Flux towers. So that has been done, I would say, for continental United States, even globally. There are products available using that approach, but it wouldn't get down to very detailed species. They have like broadleaf trees and grassland savannas. It wouldn't go to specific like grass species. Those.
Okay.
All right.
Lori, if we're going to stay on time, should we move on to Max and try and?
I think we should. Debbie, can
Is
you?
John back? I was looking at the people on the list, and I thought I saw John Keeley's name on here. John, are you here?
No, I'm wondering, could you ping him? Do you have can you text him?
I don't have his number, but I'll email him.
Okay. But I think that is a good recommendation at this point. He'll just have to come after Max if we are able to get him back on. Max, are you willing to step up here and step in a slightly unexpected way, a little early?
Sure. I was, there's some things I didn't cover because I thought John would be going first, but that I'll try to work some of that in. No problem.
Thank you.
Yeah. So I think you have my presentation queue. Yeah, great. Thank you. Okay, well, thank you for the opportunity and the invitation. I'm going to talk a little bit about fire behavior modeling, how we approach it, some of the strengths, maybe some of the uncertainties and assumptions that go into it, and then some thoughts on nature-based solutions in the context of grasslands and shrublands with respect to fire. One of the things, you see in the picture to the left there, one of the nature-based solutions that I often hear about is grazing. Why aren't we using some form of herbivory to reduce fuel loads and thus fire danger along the areas where we want to do that? And so I'm going to touch on an example of fire behavior modeling in that. Next slide. So I guess at the outset, though, I would also try to highlight one of the key reasons we care about all this in the first place is because of how it impacts people, right? The picture on the left is Paradise from 2018, and on the right it's Lahaina from last year. This is really, the tragedies that we see increasing with more people on fire-prone landscapes and with climate change. This is really one of the reasons why we care. And next, I don't have too many animations because I know they're squirrely, but by definition, the WUI, the wildland-urban interface, or intermix for less dense environments that are developed, these all abut natural and working lands, right? And so I guess one of the points I really wanted to make, one of the take-home points, is that I think we often talk about nature-based solutions for out there, out there in the wildlands, our natural and working lands. But I would offer that I think there should be increased emphasis and discussion about nature-based solutions with respect to fire along the wildland urban interface, and how we can start moving forward with some risk mitigation there. Okay, next. So since I was asked to talk about fire behavior, you can't really do a presentation without showing the fire behavior triangle. Fire people like triangles, it seems. There's actually a triangle for finer scale characterization of combustion itself. And there's a different triangle, the fire regime triangle, for broader scales of space and time, and what drives repeated long-term fires at the landscape scale. But for an individual event, this is how we think about it. Basically, the drivers are fuel characteristics, weather characteristics, and topography characteristics. The one thing that we can alter is the fuel's characteristics, right? So that often gets the most attention. But really, any change in any one of these characteristics can lead to, more severe or less severe fire behavior. And in the fuel side, we have all these different aspects of fuel, right? The amount, how it's arranged, the structure, the dryness, condition, et cetera, et cetera. Next. So the key elements that I want to focus on here are fuel amount, right? Just the quantity of biomass that has accumulated and could be available for combustion. Fuel structure, right? That fuel is in different size classes, basically, and it's arranged differently. It can be fluffier, if you want to think of it like that. It can be aerated, or it can be compacted, right? And anybody who's lit a campfire knows that you got to have it arranged just so to get it going and to get a fire roaring. It's not all the same depending on its arrangement or its compaction. And then lastly, the water content, both dead and alive. John, just before he left us, was talking about VPD and fuel moisture, but we often differentiate between dead fuel moisture and live fuel moisture, and it's pretty important for fire behavior modeling in grasslands and shrublands. Okay, next. And these are the things that we get out of these models, right? Rates of spread, how fast the fire is moving, fire intensity, a measure of heat release, flame lengths, another heat-related measure, but also flame length is used in assessing how manageable the fire is, what kind of fire suppression you're able to throw at it based on the flame lengths. And then often these fire behavior metrics are put into more than one dimension and turned into a fire spread or fire simulation model, so that you could actually get across varying topography with differing winds and differing fuels. You could actually get fire progression and fire perimeters, and you can simulate how severe, how fast, et cetera, and how big eventually a fire might get under different conditions. Next. So one of the first things, and I don't want to go too far into the weeds because it may or may not be that interesting, but one of the first things you do with the fuels is you try to characterize it as a fuel model. And what we're seeing here is an example. Each of these rows is a different kind of fuel models. So the top two are, for example, I think are both grasses, and the third row is a shrubland type. And you put it into the dead components and the live components. So the columns here, 1 hour, 10 hour, those are lighter dead fuels, and the 1 hour, 10 hour, those are the times it takes to equilibrate with ambient humidity. So 1 hour fuels are very fine fuels, right? And they might dry out or moisten up to meet ambient relative humidity relatively quickly. The heavier fuels, 10, 100, and 1,000 hour fuels, 1,000 hour fuels are very big, big branches, big logs. So you characterize the fuel into the different dead components based on their diameters. Herbaceous and woody are live amounts. There's a way during drought to partition an additional set of dead fuels throughout those different size classes. And moving to the right, the columns surface area to volume. These are all ways that you describe how aerated, how fluffy the fuels are, how compact they are. And there's some very general assumptions made about those. You're seeing some default values there. Continuing on, heat release, moisture of extinction. There's some assumptions made about how whether or not things will burn based on how much water's in them and the fuel bed depth. So for every pixel in a landscape, these parameters have to be defined. So you can imagine there's a lot of assumptions made about what goes into these, and there's a lot of natural variation out there on the landscape. So we do a decent job in many cases of characterizing fuels, and not as great a job. But this is one source of variation or uncertainty. Next. I mentioned moisture of extinction. You can see two grass fuel models here. The rate of spread is on the y-axis, and the moisture is of the finest dead fuels on the x. And so basically you don't have any spread, right? For the green grass model 5, you don't have any spread if it's 40% moisture or higher. For the red grass 4 model, no spread if it's 15% or higher. And these vary throughout the season. Through the models, you can move the grasses as they senesce from the live into the dead fine classes using a function like this that helps predict how much and how fast the spread will be based on grass moisture. We don't do this for shrubs. Shrubs have live fuel moisture handled in a different way. It's a little bit simplistic, but it's handled in a different way. I don't want to go into it right now, but it is handled explicitly. Next. And what do you get out of this? So I said you could get actual fire perimeters, but if you're thinking about, say, a case study, here is one example of what sort of outputs you would get from a fire behavior model. As you move from left to right, you have higher and higher wind speeds across the columns. And if you move from the top rows downward, you have more and more moist fine fuels. And so the darker colors there in the boxes, those are higher flame lengths, right? Those are more and more extreme flame lengths. So you can get, right, 10, 15, almost 20-foot flame lengths out of grasslands. This is for a grass fuel model. As you go towards the lower and left portions of this table, the numbers drop. And in the white, you see flame lengths that are 1, 2, and 3 feet long. Those are low intensity, and those are manageable from hand tools. Excuse me. Fire management, fire suppression can take on those lower flame lengths with hand tools. And so flame lengths under 4 feet are often sought as a goal when you're looking for some sort of a fuel reduction and an outcome that will lead to a fire that's manageable with hand tools, direct attack. Next. Okay, some issues here with this kind of modeling. The moisture of extinction is kind of a kill switch. It's very binary. And we know that there's actually more of a gradation. And we also know that under certain conditions, moist fuels can burn. The shrub live fuel moisture content, the way it's handled in these fire behavior models, turns out that shrubland fires, which I'll show a little bit of data for in a second, are really sensitive to live fuel moisture. And it's handled in kind of a simplistic way in these models. So I don't feel like, it's not that they're not useful, it's just that they're much more uncertain than we might have, say, for grasslands. And throughout all of this modeling, there's a lot of assumptions and a lot of user expertise and adjustment factors. So, you know, at the end of the day, they're useful tools, but I don't feel like they're great for giving us very specific target outcomes, for example. They're one of several tools that we might have in our tool chest for making a decision. Okay, next. So we're going to go into a case study here. Davey, you'll recognize this. I hope I'm not embarrassing Davey, but this is a study that she actually had a strong role in. And it's looking at grazing and seeing how useful is grazing as a potential tool in reducing fire behavior. And so this image here is a grazing excluded plot to get at how much biomass is removed versus how much was there in an ungrazed area. This particular study did some surveys up and down the state to figure out what the ranges of productivity and grazing effects were up and down the state. And then using some of those data, we plugged it into a fire behavior model to see what the differences might be in grazed versus ungrazed. Next. And one of the outcomes from this is just a couple of figures from the study. You can do fire behavior projections under different slope and humidity and biomass assumptions, right? And so these two are looking at a similar dead fuel moisture of 6%, a slope, a flat ground on the top, and in the bottom figure is a 100% slope or a 45-degree angle, pretty steep slope. And the y-axis shows you fuel loading and the x-axis shows wind speed. What's useful here, that one of the outcomes of this is the dashed lines and the solid line. The solid line shows you where a 4-foot flame length is achieved, right? So you might graze these landscapes, for example, down from 2,000 pounds per acre down to 500, right? And based on the slope and the humidity assumptions that you're going to use for your scenario, you might be able to say something about whether the grazing at that level had the impact you were hoping that it would. For example, you might want to graze it down to the point where it's easily suppressed with hand crews. For example, that's one of the outcomes. Now, there's other scenarios you might play with this, but through with this. But these are the kinds of things that you can get out of fire behavior models, and decide whether strategic grazing in a given area makes sense or not. Next. Some of the examples that I'm going to show here come from a study area in my part of the world, in Santa Barbara and Ventura, where we actually have had fires, and we have grazed landscapes abutting some ag belt portions of the wildland urban interface. And it turns out that the agricultural belt along the WUI is a nature-based solution of sorts, and grazing the herbaceous landscapes on the outside of that is another way to increase the usefulness of that kind of as a buffer, as a green belt. Next. So for shrublands, I've already said that the approach that is taken through the kind of the typical Forest Service fire behavior modeling tools, it has some strengths, it has some weaknesses. I'm going to present a different way actually to look at fire behavior modeling in shrublands, and it's very focused on live fuel moisture. So next. And one of the reasons for this is people have known for a long time that the amount of moisture in living shrub tissue is actually really critical to how the fire season progresses. Now, this is a look at live fuel moisture. The different squiggly lines here are different sampling points in Ventura. This is from Ventura Fire, and how it greened up after the rains, and then how it's dried down since during our dry season. The green bold line that's kind of smooth in the background there is the long-term average, historical average of the sampling. But some of the things you note about these figures is they're coming from data that's taken every 2 weeks up and down the state. Many, many agencies do this. There's almost always a red line at 60%. That's the moisture content level at which people call the fire season having entered a critical phase, because once it dries down to that point, fires can really take off and be very difficult to suppress. But this live fuel moisture approach to modeling fire behavior is one that has gotten more and more attention lately, and I've spent a little time looking at it too. And by the way, that some rain would be nice. This particular figure didn't have anything in the fuels fire discussion box, so that was my small addition, which is not official, although some rain would clearly be nice. Next. So one of the projects that I've gotten involved with in modeling live fuel moisture and how it plays out across the fire season, this is a figure from that study. We ended up using samples of live fuel moisture for several decades over a very large landscape and modeling how it progresses through the fire season on shrubland dominated landscapes, mostly landscapes that are have a strong chemise component, Adenostoma fasciculatum. And this is the landscape. Next. This is kind of one of the punchlines of the story. If you imagine live fuel moisture, LFM, on the x-axis there, imagine at the beginning of the fire season, everything's green and quite moist, and you're at you've kind of at a normalized 100% maximum fuel moisture. As the season progresses, those fuels dry out, and you start getting cumulative area burned, which is on the y-axis. You start getting small fires that are starting to add up little by little to greater amounts of cumulative area burned. And that at some point, this is through a broken stick kind of regression analysis, a segmented regression. At some point, that dotted line there at it's at 42.29 or at 76.93 LFM, at some point you cross kind of an ignition threshold. And that's somewhere in the 75 to 95% live fuel moisture. And that's very consistent. We've done this for cumulative area burned, for numbers of fires, for sizes of fires, and so on. And there's always a threshold somewhere in the 75 to 95 range, which we're interpreting as an ignition limitation. It's too moist for fires really to take off. Then there's this intermediate domain where fires are getting larger and there's more of them, until we get a second threshold that's actually consistently right around 60% LFM, that red line on those fuel moisture seasonal figures that I showed earlier. At 60%, it takes a big jump. And so we see this over and over, and actually it shows us just how sensitive chaparral fire systems are to the amount of moisture in the living leaves and twigs. And you could imagine climate change can actually affect this, right? Because if we end up having longer, hotter, drier fire seasons, these thresholds will get crossed more easily, and we'll probably have larger, more area burned and bigger fires. Next. Another thing that we've done to sort of corroborate these thresholds that we see at the landscape scale is we've started burning plants in a flammability chamber, which we've built. And this is some work that we started doing in conjunction with the local botanic garden, because they want, of all things, they want a plant list. And actually, many of you have probably run across these fire smart plant lists. Well, they're not based in a great deal of science usually. And some of them are actually terrible. They have non-native, non-local, or even invasive species on them, or drought tolerant species, which aren't necessarily, good from a flammability perspective. Next. And we're starting to generate some fire behavior metrics. This is proportion ignited for different species at a certain level of moisture. So we're starting to come up with a way to actually look at these gradients in flammability, which has a bunch of different characteristics actually, that we can translate up to the landscape scale for natural lands, or we can actually use for recommendations for landscaping around homes. Next. One of the nature-based solutions I think that doesn't get as much attention is shaded fuel breaks, for example, with native trees. Here we have coast live oaks as a shaded fuel break. Basically, it's been limbed up, and these can, like an ag belt or golf courses or fields, these can also be buffering the WUI as a nature-based solution. Next. question of whether do they work? Well, actually, in the bridge fire a couple of years ago in Santa Barbara, we had a sundowner-driven fire blowing hard, fast, downhill, burning through dry, herbaceous landscapes, and it hit a coast live oak buffer and basically went out. And if you'll notice here, what's on the other side of that coast live oak buffer, there's a neighborhood. If it weren't for this buffer, that fire would have become probably an urban conflagration under high winds and been a disaster. So I think, you know, again, these nature-based solutions along the WUI are something that we don't hear a lot about, but I think they should be something we're focusing on more and more. Next. All right, some concluding thoughts. We can model fire behavior. There are a couple different ways we can do it. There's some very standard tools, and there's some other more researchy tools. I think they're probably best used as rough guidance, right, as opposed to very specific target conditions in very specific places, but they are useful. Nature-based solutions for the WUI, the wildland urban interface, I think are underappreciated and important. And I think that's all I have.
I think we are thanking you. That's terrific. I think we have a few questions from committee members, and so why don't we go there initially? And Laura, I think you are number one.
Thanks, Max. It's nice to see things pulled together and a great message. So really appreciate that. I was wondering, you commented on the study that looked at these breakpoints and kind of highlighted the fact that chamise is sort of the anchor vegetation type for the kind of relationship between fire area and live fuel moisture. And I was just wondering, you know, based on your understanding, judgment, other data sets, you know, the degree to which landscapes dominated by other types of shrubs might follow a similar path, or how much difference there is, or if that's still an unknown.
That's a great question. It's something we spent a little bit of time on. And for example, we've used this chamise model because you can predict what chamise live fuel moistures would be on any landscape, really, whether it has chamise on it or not, right? We just happen to restrict it to the areas that we know that it's an important component of the shrublands. And it doesn't work. So what that's telling us is that we don't want to do this for every species. That's just too much, right? But we would love to find some kind of key indicator species. And it looks like chamise is pretty darn good for these landscapes. There's probably a couple of others that we need for other shrub-dominated landscapes and forested landscapes. The challenge there is that chamise is sort of the poster child for live fuel moisture sampling, and lots of agencies that go out and do this every 2 weeks target chamise landscapes because it's comparable, right? Then you're looking at apples and apples. It's very widely distributed, but there are not nearly as many live fuel moisture samples for other vegetation types. And we also know that snow-dominated systems will react fundamentally differently too, in terms of green up and dry down. So there's some good studies still left to be done, trying to figure out those other landscapes.
I guess I was also wondering if any of the flammability testing provides a bridge in any way.
With other, like if we were to actually test, oh, I see what you're saying. Look for thresholds. You know, we haven't tested as many plants outside of shrublands as we could, but that would be a good way to do that, though.
Yeah, or even, yeah. I mean, I guess I'm most concerned about shrublands, given what you were saying about snow-driven systems, but just, you know, shrublands in other parts of the state that may not be chamise dominated, for example.
No, I think we probably could. We could begin testing those in the chamber, right? In the flammability chamber to see if similar thresholds appear to emerge from that kind of a testing. I think the short answer is yes. That would be insightful and important. The other thing I think could be useful is remote sensing of live fuel moisture. I think that there's some new ways to try to do that. The fact that it's trying to detect the moisture content relative to the biomass dry weight within woody stems, I think adds a lot of complexity to it from a remote sensing perspective. But my understanding is, I work with Dar Roberts at UCSB, that he's got some methods that are approaching, I think, on the 60 to 70%, explaining 60% to 70% of the variation in live fuel moisture with a remote sensing product, which could be useful to get us some of those other landscapes.
Thanks.
Mark?
Hi, yeah, thanks, Max. That was a great talk. So your talks are thinking about something else besides what we talked about. So I'm gonna ask you a question that's not really related to what you talked about, but I'm just thinking that if you have these different fuel moistures and then flame lengths, that presumably you have different levels of fuel consumption and different both amounts of carbon retained on the landscape and in different forms. I'm wondering what we know about how doing something like use strategic grazing to reduce fuels changes how carbon stored on a landscape after fire.
That's a really good nuanced issue. So what we've seen after grazing, obviously the amount of fuel has been reduced. And often, one of the key differences in a post-grazing landscape is also that it's been trampled and compressed and compacted. What fuel that wasn't removed is often now not as flammable because it's laying down and it's compact, right? And so sometimes you end up without as complete a burn as you might have had. It can be lower in intensity and lower flame lengths and lower rates of spread, but it also might not be as complete, which, depending on your goal, may be a good or a bad thing, right? Maybe you want to leave some of that on the landscape for erosion, to minimize erosion. Or there's also in woodier tissues, high intensity fire can produce a small amount of black carbon, which is a pretty stable form of char for on the order of centuries, right? So you can actually look at some fires, mostly in woodier ecosystems, as fixing a small amount of carbon with each fire too. So the grazing part, most often the trampling of the fuels is not accommodated, at least in the modeling part of it. And it does actually alter the way fire would behave on that landscape.
Great. Thanks.
Yeah. Are there other questions from committee members in the room? Then Max, I'd like to ask a question. With this committee, in many respects, we've been looking for the perfect intersection of enhanced climate resilience on the landscape, so inclusive of carbon sequestration being more resilient, inclusive of biodiversity, community safety, and you've flagged that vineyards or other agricultural zones can be viewed as fire breaks or diminishing the spread of fire, and that grazing is that. And then you also flagged fuel breaks within native vegetation types. My understanding is that or let me pose it as a question. Certainly shaded fuel breaks in forest systems are have been relatively well developed. What about chaparral systems?
Yeah, so if you were to take a shrubland and try to have a mini shaded, create a mini shaded fuel break out of it, I think most of us don't think that would work. I think if John were still here, he would say that's just a bad idea.
Yeah.
And it probably would not work. I have seen landscapes where they've kind of tried to savanna-ize, create a patch mosaic of thinned shrublands. And I think you have a lot less carbon being fixed. You have, much less habitat and ecosystem services being provided. And it's actually not really probably going to function very well as a fire break. So I think one of the approaches that we have been trying to implement on our landscapes here is that, let's say you do have some native shrublands that are intact and providing the services that they're providing, almost always along the wildland urban interface. So there's some potential for a weedy grassland, right? And those are the places where either we're targeting to enhance a coast live oak stand and expand it, or actually to initiate plantings and irrigate for a few years and try to establish coast live oak shaded fuel breaks. Because we've got two sources of evidence in our part of the world. We've got some older firefighters who will, put their foot down and say, no, I've seen it happen over and over and over. They will burn under the worst conditions, but more often than not, they're a place where fire lays down and it either goes out by itself or it gives us a place to work. And we've got the image I showed there from just a couple of years ago. We saw it actually happen on an extreme wind-driven fire, burning downslope into a neighborhood, and it basically went out almost on its own when it hit this stand of coast live oaks that was really not maintained very well. So I think it's an underappreciated tool in the toolkit that we haven't really figured out yet.
Well, it's interesting in our recommendations where it came to coastal scrub chaparral systems, our goal was to minimize fire in these systems, period, as opposed to montane per se. And our focus has been very much on promoting the utilization of species native to that area. In terms of how this is approached. And my understanding is that the biggest problem in our coastal chaparral and scrub systems is too much fire from the missing square of your triangle, which is people's actions and behavior. And when we talk about fire model and fire spread, the people are the perhaps in terms of the ignition, the single biggest portion of that. But it sounds like you would concur with the recommendations that are in the report that we put forward relative to chaparral.
I would. I think that another underappreciated dynamic is that fires often come from the built environment, from where the people are out into the wildlands, right, out into those shrublands. So actually a well buffered community along the wildland urban interface with various types of green belts, let's say, is another way to actually keep fires from actually going in the other direction and getting out there and adding to the already too much fire that there is on many of those shrubland landscapes.
Are there other questions from committee members, or do we have any questions from the public if there are none from the committee members? I'm not seeing any hands raised on the screen. Are there any members of the public in the room that you can indicate have a question?
Yes. Before we move to the public, I did see Matt did have his hand up. I think that's the last committee member that has their hand up. Is that correct?
Yeah, and I'm sorry. It was just to draw attention to a comment earlier about the vapor pressure and any correlation between those measurements and so-called forest thinning sites, where we drive in with heavy duty equipment and we rip the forest floor up and we evaporate where I know all the water is in the forest. But we call it fuel. It's been relieved of its fuel burden, and then it still burns like hell. And so I'm combating in very real time vulnerable rural California communities who have been decimated by wildfire who are being told that if they don't cut down the rest of their forest in the ugliest, most cost-effective way for extractive lumber, that they don't care about wildfire and that they're going to burn everyone's homes down. And so I think there's a real opportunity for remote sensing to prove that there's water in the soil and we shouldn't dig it up. But also that there are better ways of evaluating forest thinning, not by dead tonnage, right? Like there are lacunarity analyses that talk about, they can show us the gap between the floor and the fire ladder. But this complication this question kind of ballooned as I started talking to you. But I was intrigued by your comments about vapor intensity and feeling like that's some of the missing research that proponents of forest thinnings are just glossing over at the expense of my communities.
Debbie or Max, did you want to respond to that, or Yifan?
I wasn't really sure if it was a question for me, or I basically agree. I think there's a lot of issues with looking at vapor pressure deficit as a metric. It's great for looking at evaporative demand as a surrogate for evaporative demand, based on temperature and humidity. It doesn't necessarily tell us all that much about rainfall patterns, in the preceding spring, which say a lot about how long and how hot and how dry our fire season might actually be. And your points about, the way I interpreted it anyway, about over thinning, I think for a long time, people have known that, you can go in and remove surface and ladder fuels to try to lower fire hazard and keep fire, if it does come through there, from becoming a crown fire in the overstory. But you can over thin, right? You can actually start removing bigger and bigger trees and letting in more and more sunlight, so it becomes drier. The wind speeds increase in the understory as you thin that, as you increasingly thin that out. So you're right. There are trade-offs in thinning that we would have to keep in mind.
Thanks. I felt pretty lonely having these conversations with proponents of these from other state agencies.
Debbie?
Thanks, Max, for your presentation. That was great. I was intrigued by you bringing up the shaded fuel breaks. It's something that I often forget, I think, because I'm working in the really large scale rural landscapes and not at the WUI. But I've seen a couple of shaded fuel breaks, and I've heard some people talk recently about, what about using grazing to maintain shaded fuel breaks as kind of a win-win, and kind of combining two different nature-based solutions. And I'm wondering if you've seen that before, if you have any thoughts about that.
We have so few examples of mature functioning shaded fuel breaks along the WUI that I haven't seen it. I haven't seen studies, or I haven't seen examples of it over larger scales. I think it's a perfect application, though, right? Of combining one nature-based solution with another, or combined, it is a nature-based solution for reducing fire hazard at the WUI. I think it's a great idea.
Thanks.
I'm going to ask a quick question, if I may, on that. From the grazing point of view, goats are increasingly used within urban systems and some WUI. Is there any knowledge about the different impacts on soil from cattle versus sheep versus goats, and their preferences about species, what species they prefer to eat in terms of the biodiversity values of using these for fuels reductions in both urban and WUI contexts?
So just recently, I was at a field site where a goat herder was telling us all about why his herd of goats on this particular landscape made so much sense, and it had to do with what they were willing to eat, what their target species were, whether they were going to target non-native invasives versus some of the native species we might want to keep around. And I know there's differences between goats, sheep, and cattle. I would actually probably defer to Davey for some more nuance here. I know there are differences, and I'm sure it's documented to some degree, but I'm surprised at how little that knowledge or how few people have awareness of that, at least in this part of the world. Not to put Davey on the spot, but I know there are differences. I just don't get the feeling that it's a very established and standardized set of knowledge.
So in terms of what the different animals consume, cattle are grazers and they're really focusing on grasses, but of course they'll eat forbs as well, and they'll take bits of shrubs and trees here, leaves here and there, but they're going to be focusing on the grasses. Goats are browsers, so they're going to be focusing on the shrub species, and then sheep are kind of like, they'll go for grasses and forbs, and they're kind of more open in terms of what they're interested in eating.
I think they call them living locusts in some
There you
places.
go. Oh yeah, for goats maybe. That's funny. And then in terms of soil compaction, I'm afraid to say anything because I can give my hypotheses, but I don't have specific data to show. And just to pass the buck one more time, Chelsea might know more about that from the soils perspective.
Yeah, I think the differences will depend on how they're grazed, right? Like, so it's, not just the species, but how many of them you have, how long they're there on the landscape. And so what the conditions, like, is the soil wet? Is it dry? Right. So I think it'll depend a little bit, not to give you an unsatisfying answer.
So I suppose it's one of those, assuming all conditions equal, the impact of cattle versus sheep versus goats. But if anybody has, Chelsea, if you have that grounding to share with us.
I'm not sure that I'm prepared to say one way or the other. I have to think on that a little bit.
I think there are no more questions from committee members. Is that the case?
I have a question. Hi, Lori. It's Carrie.
Okay, thank you.
So Lori asked actually a lot of the questions that I was thinking about. I have a question for you, Fang, actually. And also for ARB. So first of all, how would you use the approach that has been presented by you, Fang, in your efforts? Like, what are you looking for out of a model like that? Or, are you planning on scaling that approach up to other wildland systems? So I guess that's the question for you. And then for you, Fang, I was wondering if your approach could be, through Sigma, there will be fallowing of land in the southern Central Valley and potentially elsewhere. We know that European annual grasses can survive and do their thing on very little rainfall. We use your approach to identify or sample different data layers for temperature and precipitation and soil to identify where lands that are being fallowed would be best, managed in a certain way using certain healthy soils practices or, certain kinds of grasses, that sort of thing. Like, is there a longer term adaptation for your methodology that can meet some of the goals of what the state wants to do? And I think we have answered some of this through Lori's questions. I feel like I need a board because I'm waving my hands all over the place. But, and also, I know you've done some work on almonds also, and it seems like this approach could work for other tree crops and other perennials. So I guess maybe it's a comment / question for the room.
Yeah. So do you want us to speak from the state side first?
Sure. Yeah, that'd be great. I'm curious because even the states you've been saying, oh, we need data. So what is this talking? How do you plan to apply an approach like this to the large spatial extent of California?
Well, yeah. So the state, right? We have a couple of different sort of related efforts for quantifying things like forage production, carbon, and that's through our carbon inventory. So taking sort of historical look at how things have been changing on the landscape, and then a related but separate effort with the scoping plan, right? How are things going to be changing going forward? And to the extent that we can leverage remote sensing to inform those estimates, we'd like to, right? We're looking for creating the most accurate estimates we can using open source information data. And so I think something like this is certainly things interesting to us, right? And it's one of those things that we'll go back and we'll sort of look at, and we can compare and contrast with the other options that we have on the table. And so certainly I think this was very interesting. And one of the other things that we need to be able to do with this, which you found, I had some, you had fielded some questions about, right? But is with the 1757 targets is track management impacts, right? So not just how is forage production changing with climate, but how is it responsive to management? And I know that that's a challenging endeavor to get management information. One of the questions I had as I was listening to the presentations is whether or not we can remotely sense things like residual dry matter, which are related to grazing management. We know influence future forage production in the following year. So I really appreciate the presentation, and I don't know if that answers your question sufficiently, Carrie.
Okay. Yeah, just to follow up on the tracking management impact on both carbon or potentially water, other ecosystem services. I think it's possible to track those impacts. The challenging part is getting the management layers. Some of the like a change in the landscape, we can monitor from space because we are doing almost like a daily observation and estimation, right? So we can detect a change, but if it's too subtle, it's more challenging. And also attribution of those change is another task that needs more effort. So it can be disturbances or change in landscape can be from management actions. It can be from weather impact, right, and many other factors. So there are approaches potentially can separate those different impacts, like identifying where the management actions or magnitude of management practices are on the landscape, and then we can assess what's the impact on above ground biomass or water related, like evapotranspiration, using remote sensing data as well. So with regard to RDM, residual dry matter, which is actually one of our another objective for the Western SARE grant. So we are trying to bring together like a time series of optical data, because we can track the production, and then at the fall season, we will use another approach, bringing hyperspectral data. So it's combining the production and then weather decomposition along the way. And then at the end, we also have hyperspectral data looking what's really on the ground. So there's a approach that we are trying to develop to estimate RDM, because it is a very important like a soil health indicator. So I think that there's a lot of opportunities over there to get an estimate on that, especially using newer sensor systems. So that's just some follow-up questions on that. And then the other questions about the fallowing, is that the impact of fallow in agriculture, including grasslands, especially in the context of SGMA. Yeah, I think we can track even the change of land use, land cover, right, from remote sensing data, and then we can also monitor water use, consumptive water use, using remote sensing observations as well. So we can actually assess the impact of fallow in certain crop type or grassland, the impact of on water balance. And if you're interested in other ecosystem services, above ground carbon is relatively easy. Below ground it's relatively harder. But yeah, if we can, the nice thing about remote sensing is you can like estimate pretty much everywhere on your landscape, and you can always track it through time. So with like a more statistical approach, then you can move on to questions like understand or assess which area would have larger benefits if you convert this to another either fallow or to another even type, right? So I think there's a lot of potential over there. Yeah, on the fallowing side in the context of either Sigma or carbon sequestration. I'm not sure if that answers your questions. And the other one, yeah, it's really, I think the overall concept with lots of remote sensing applications is, I would say it's pretty similar, although you need to tailor your algorithm to particular ecosystems, right? Like I do rangeland applications. I also do forested landscapes, looking at the fuel load, fuel structure, using a wide range of remote sensing systems, and also similar question looking at the impact of fuel thinning prescribed fires on carbon and water balance, right? So it's pretty much very scalable approach. I also work in agriculture ecosystems. We are looking at forecasting or predicting almond yields using flowering conditions that we can capture from remote sensing imagery, and also tree growth stress from multiple remote sensing systems. And then with large database, we can look at the impact of weather on flowering and also for production, right, or the phenology. So yeah, I think overall there's a lot of potential with this remote sensing monitoring assessment tools, and then combining with machine learning models that you can integrate many other environmental covariates to understand the processes and also predict, right, to the future.
You know, Yifeng, one of the things that would be, I wonder if your data does reveal this or not, it ties back to Matt's question about extreme unexpected events. So separating out, you know, heat domes, whether it's days or weeks, and looking at that as opposed to on the annual average, but identifying what differential impacts those have on which systems and how natural or disturbed those systems are in terms of their response to these extreme, whether they're heat events or precipitation events, yes, that are increasingly common. So is that something that you can detect out of the broader pattern?
Yes, I think that's actually one of the questions we are very interested in investigate down the road, looking at those individual extreme events and also the compounding events, right? If you have drought, and then on top of that you have heat waves, and then looking at the impact of those extreme events on different ecosystem functions. So with the like a time series of estimation from satellite, I think, and then the daily or even hourly weather data, I think it would be interesting to look at that. We did a study actually looking at the ignition risk. My former postdoc convened, I think Lara knows him. Unfortunately, he joined the faculty position later, so we didn't publish that. So we did look at extreme heat waves on the ignition risk. That's although it's less remote sensing project, but it's similar concept. Yeah. So we look at individual counting, like you can set whatever threshold, however you want to define the extreme heat, like there's a duration and also the magnitude, that heat, right? And then we overlay that with ignition data. So we did some modeling work on that, yeah.
Well, given our time here, and we want to come back while we still have Lara and Marian after a break. But Matt had a point and Max had a response. And I think we have one comment rather than a question from a member of the public. So can we accomplish this within a few minutes?
Yeah, mine is super quick, Yufeng. I'm really enjoying your learning about your research. Just wanted you to know that we can do a lot better than ambient or daily average temperatures with the Jet Propulsion Labs the high test sensor that they have. We're getting sub-meter data, and we can get it down to really small increments of time. So you can get down to wet bulb, and we can start looking at like real-time fire risk, which I think would be really exciting.
Yes.
You know, there are remote sensing potentials and there are satellite potentials, but they work best when we have them both working together.
Yeah.
And Max?
Yeah, really briefly. I mean, Lori, you brought up ignitions, and Yufeng, you just did too. At the risk of adding yet another nature-based solution, there's a lot of interest in revegetating kind of these weedy, degraded landscapes where most of the fires begin, right? Along roadsides or even along fire breaks, which are infested with, you know, non-native grasses and can carry fire into places. The Forest Service is looking at ways to assess flammability. And so we're actually looking at this with a new project, trying to figure out which native species, you know, subshrubs, you could revegetate some of these areas with that would be less flammable, less ignitable, and, you know, providing some pollinator and some carbon benefits that would not otherwise be there. And so, again, kind of looking at the plants as a potential way to solve a problem instead of the plants as the problem.
Yeah, that's very cool.
Oh, yeah.
And Brian, do you have a question for any of our speakers, or if it's a generalized comment, could we keep it until later on in the program?
It's short, if I may bring it up. It's regarding Yufeng Jin's presentation.
Okay. You've got 320 seconds.
Okay. Yufeng Jin's presentation emphasized the climate effects such as higher temperatures and lower precipitation. And those were addressed in her presentation, but unaddressed was the effect of increased atmospheric concentration and the proven ability of grasslands, pasture, and chaparral to capture or biosequester carbon. This was briefly touched on by Chair Wayburn. This impact has been addressed by work from Dr. Trevor Keenan of Berkeley, showing, for example, that plants are photosynthesizing more in response to more carbon dioxide in the atmosphere, 17% more from the increase of the CO2 in the atmosphere from 360 to 420 over the years the years of 1982 to 2020, and this increase totaled 14 billion tons or gigatons per year of CO2 capture by plants, just from the ambient increase due to emissions contributing to the environment. So that needs to be addressed because chaparral can increase. And in fact, this is a point that I made in a public comment to this presentation, to this meeting, showing that crop carbon dioxide enrichment indeed can be used to tweak sequestration in natural and working lands and actually capture billions more tons of CO2 using nature-based systems.
So if I understand you correctly, you're referring to CO2 fertilization impacts that are happening in an unmanaged way, but have that impact on the landscape. Is that correct?
That's correct, and it also could be used in crops. It's been done by USDA for 40 years with free air carbon dioxide enrichment. I provided a comment in writing to the meeting website with literature references. So this is a very good way to use nature-based systems to capture carbon, and it may even be a silver bullet if it's direct air capture is currently being funded by California Energy Commission. And my company and others are actually using this enhanced direct air capture by adding CO2 to crops and to forests to enhance the capture.
Thank you for that. Thank you for that. If there are no other comments at this juncture, I'm going to say thank you so much to Max and Yufeng and Devi for pulling an excellent panel together. I'm really sorry about John Keeley, so I hope that at the very least, I believe his presentation will be distributed to everybody and he's available. But thank you guys so very, very much. And I believe we're going to take a 15-minute break. So Lara and Marian, you'll be on the hook. Capture you for a little bit. All right. Thanks, everybody. 15-minute break.
Lori, we have yet to convene back here in the room. I think folks are thinking at 3:25 they're planning to be back in.
Good to know. Thanks. Right. All right. Everybody in the room is back, and most people on the Zoom are back. So why don't we restart? And I know you've got a kind of, there you go. We can leave that up for a little bit, but this is primarily discussion, so I don't know how long we'll need to keep that item 3 up there in lieu of people being able to see each other a little bit better. Maybe you can take it down shortly. I think one of the really positive elements out of our elections is the passage of Prop 4, which gives the state significantly more funding to be able to undertake implementation of some of the kinds of actions that were identified in the nature-based solutions announcements that the governor put out on April 22nd. And so I think our conversation here really is to do 2 things in my mind. One is to get your thoughts on kind of the high notes of those recommendations, because there's a lot there. Two is I'd like to, we obviously do not have the state's draft for the update to the Climate Smart Land Strategy, but perhaps they could quickly identify when they think that might be available. And then that would give us the opportunity to also look at intersections between the update and the recommendations that or the targets that the governor put out and the recommendations that we put out. So I'd actually like to direct this to CNRA. Do you have a sense of when you might have the draft of the update to the Climate Smart Land Strategy available?
I do. Okay. Is that better?
Yeah.
Okay.
Yes.
I do not at this moment. As you all may have heard, we've had some like personnel shifts in our office. Amanda Hanson, who is the Deputy Secretary for Climate Change, is serving in a role at the governor's office right now for the next several months. And our Assistant Secretary for Climate Change at the Resources Agency is on leave. So we are down to me plus one other person for now. And a few other folks at CNRA helping to cover various items. So we have, a little bit of a capacity issue to deal with. That said, we are also working on getting sign off from the various entities in the interagency and the governor's office on the draft before we can release it, which is a bit of a hard timeline to nail down. So unfortunately, I don't have a specific date besides, as soon as we can is really what we're working towards.
But you think you have a draft that's not going to change much, it's just mostly getting signed off on as opposed to?
That's my hope. It's hard to say, it's got to go through many layers of internal review and things can change.
Well, at least we would trust that Amanda's review, standing in for Lauren Sanchez, would be relatively direct.
Yes.
Yes. So you've got an inside line to the governor's office there, which is a positive. Well, Carrie, I think that is somewhat responsive to your question, which you had, we had been charged early on, and Amanda had specifically said that one of the things she was looking for from the committee was our commentary and review on the Climate Smart Land Strategy. And so given that we have an unknown delivery date for that draft, I'm not exactly sure how we are going to be able to address that as a committee, because I believe, and actually, again, the state could possibly clarify this, that the committee disbands later this year or as of this meeting. What is the context of the committee's constitution on this?
Yeah, so the committee was a 2-year committee. So this is the last scheduled meeting. And it will run through the end of this year. I will say, and I think hopefully I've mentioned this in the past, is a lot of the recommendations that the committee gave alongside the specific targets. I'm specifically thinking of some of the implementation pathway recommendations were particularly relevant and helpful for the strategy update. So we were able to use those both for the targets that were released earlier this year and as we've been working on the strategy update, because you all went, into implementation of it.
Let me ask just a small question here. We were constituted in April a year ago. So I guess it depends on if you consider this to be a 2023, 2024 assignment or if you consider it to be a 24-month assignment from when we had our first meeting.
Yeah, I will go back and ask our lawyers this question. I believe the first meeting was February 10th of last year, 2023. But I can go back and clarify with someone on our legal team. I'm not 100% sure of that question.
Well, then that would be great to clarify, because it would just either give people the, okay, come December 31, that's that, or okay, February X is, it's Y. And that would be helpful. Carrie, I know you had some questions about that, and Matt, I saw your note that this was your question. 2 years may mean how many hours are in there, because they don't work, 8-hour days. They often work like 12-hour days. So maybe their 2 years happen in a year and a half.
Yep. Or they disregard 2 years of input. I'll just tell you, I've been a part of committees. This can be extended. We can have a resolution and we can pressure them to extend it, but we all know the agency doesn't want to do that. So that's where we're at.
Well, it would be great, Clessie, for you to come back to us with that. And Carrie,
yeah, I'm just sorry for all the great input you guys have given for it to be treated this way. It's been a wonderful set of input from the academic community on behalf of California, and to watch it fall utterly flat and for there to be zero embrace or attendance from the Air Resources Board and its economy-wide staffing, which is a deep roster. I am deeply disappointed in the process facilitated by the Natural Resources Agency.
What I'm hearing, and so Matt, I'm not disagreeing with you at all, but what I'm hearing and what I saw in the targets was that the targets that were announced by the governor was a good deal of the work which the committee has done has been embraced by the administration. I don't know how that translates to ARB, and we don't know how it translates to the draft on the Climate Smart Land Strategy update. But if we take what Clessie just shared with us, then I would think that every member of the committee should feel that their input has been has had an impact with that. So,
Lori, I think that you addressed my question that I had shared with you. It was just to know what kind of guidance we could get on if we needed to, like what our next steps or expectations were as we're finishing up. So thank you for bringing that up.
Well, one related question to that, this is again, perhaps something that Clessie, you will say needs legal advice, but assuming that this runs through February of next year, or if it goes to December. I know my time in December is very, very limited, and probably other people's is too, but would the committee want to, as a committee, provide feedback on the draft once it is issued, if we are still within our, shall we say, legally constituted timeframe? So I'd like to get feedback, one, on what your comment time period is, Clessie, when this eventually is released, and two, from committee members, would you want to engage at a committee level, which is to say collaboratively, in response to the Climate Smart Land Strategy update?
Lori, I think maybe a clarification is also if there is a place where our comments would go, is there a process where they would be reviewed instead of just making them and I think that's something that we would ask you all. If we do make comment as a committee, is that going to be received through some sort of formal process or just so that we're not just sending it out to the ether? I mean, does that make sense?
Yeah, I mean, all comments that we receive are reviewed and integrated.
I wasn't sure if it fit in your timeline of all the different things you have going.
Yeah, I mean, I think I read that as more of a question to the committee members. Would you all even be interested?
So there are two questions. One is, Class C, is it a 60-day comment period, a 30-day comment period? What is your comment period for the draft? Once it's released?
I don't know for sure, but my hope is that we will be able to hold a quite extensive comment period to the tune of 45 to 60 days is my hope. But I cannot make that decision unilaterally.
Okay, so somewhere in that 30 to 60-day time frame is kind of pretty typical on comments. So then the next question really is to the committee members. Would you want to, our choices are no comment, our work stands on its own. People comment individually as, members of the expert committee that made recommendations, or that we do something collaboratively as a committee in response to those, to the draft. And of course, numbers 2 and 3 are not mutually exclusive. One could always pull one's comments out. But I would really appreciate it if we could go around the committee and get feedback from you all as to what your comfort or desire is in terms of any feedback on the Climate Smart Land Strategy, because that was a key thing that was teed up that the committee was going to be asked for input on, early in the year. So since I can only see boxes on the screen easily, what I'm going to suggest is that we go around. I can see, Mark, you have your hand up. Do you want to chime in?
Yeah, I was just thinking that what I just heard from Clussy was to say that all comments would be listened to, which makes me seem as though if you were to receive a comment from this committee, that would be viewed as the same as if I got a group of 10 of my very close friends who happen to be on this committee together and we submitted it as private citizens. And my willingness to work as a committee on this depends on your answer, really, on whether are those two the same things, because I would think they're not.
Yeah, and I can't answer that specifically because I don't know legally, and I would need to get into the specific charge of the committee and the legislation. For instance, in the targets, we released the committee's recommendation as a standalone appendix. We did an assessment of where our targets aligned with or did not align with. The committees, we did not do that for all general public comments. I think that's something we certainly could do. I would want to, double check before I make that promise. But that's, it could be something similar to what we saw with the target recommendations.
Well, I guess I would like to ask that you put that in the docket to do, because I think that actually is important. What we end up doing.
And then we have John.
Yeah, I think Mark's question is important, but my preference would be for the committee. I mean, we've put all this time into it, and that was a specific request, so it seems like it would be worth the time to have the committee provide specific input as a committee. It seems like that would be more valuable or more impactful than a bunch of individual comments. And I know it was very useful to get feedback across the committee. I mean, I think we gave much better input providing a little discussion amongst us to provide it rather than individual comments.
Laura and Marian, I'm going to put you guys on the spot because I know you're going to be leaving shortly, and I would love to get your points of view.
Yeah, I'll chime in. This is Marian. So I think I'm with John on his comment too. I think that there's a lot of expertise and understanding that this group has received as a whole, or has generated and developed as a whole. I would be given all the appropriate boxes that are checked and the legalities are appropriate, I think it would be powerful for this committee to submit a whole of committee comment on that, and I'd be happy to participate in that.
Thank you. And Melissa, I can't remember, you may also need to leave early, so, but Laura, your thoughts?
I don't think I have any thoughts other than what's already been stated. And I would be willing to continue in a conversation with the group. If there isn't a legal group after some deadline that wouldn't enable us to, operate as a committee. I mean, I do feel like there may be, even if it wouldn't be treated exactly the same way, there might even be value to submitting a comment as the former members of the executive advisory committee who provided input to the, or something like that. So yeah, I would be happy to participate in something like that. So.
Thank you. Melissa, you also need to leave, so can we tag you?
Yeah, sure. I would agree with what has mostly been said. It sounds like we generally are happy to collectively put something together, and I think that there could be some impact in that, but I also would be curious from the agency staff how they would receive that and what their sort of goals, perceptions, timelines, outcomes, desires would be like as it pertained to our committee. We could do it either way, but it's always nice to understand the landing place prior, if possible.
I've got Debbie and Matt still on the screen. I'm not sure about our other committee members outside of that, and then let's go to inside the room. And Matt. So Matt and Debbie, could you please give us your thoughts?
Yeah, I was just going to say that I like what I'm hearing here. I mean, you could absolutely request an extension of this committee to provide rolling oversight of the integration of the EAC recommendations into CARB scoping plan, natural working land strategy, to make sure that it gets in there. Somebody else might go out on leave, right? And then because of that, everybody's input gets lost. But maybe there's a way to do a concentrated commenting package with, the appropriate representatives from this committee to help kind of keep an eye on these recommendations, because I'll tell you right now, it feels like this is all getting thrown away, and I'm not happy about it.
Yeah, I appreciate that, and I appreciate your comment, Laura, that I think even frankly, the shorter and the punchier, the better, in terms of the review. And if there are things that are nice ideas but low on impact, we can say that. We considered it. It's a great idea. However, there are barriers or things to that nature. But Debbie, your thoughts?
I agree with what everyone's been saying. I think that as a committee, we've done a lot of good thinking together and supporting each other to come up with some, I think, really good recommendations in the past. And so I like the idea of working together as a committee to provide comments again in the future. I think there'll be stronger comments if we work together.
I generally think that is true. I'd love to hear from William and Carrie directly on their feelings about, participating.
I agree, and I would enjoy, and I think it's a reasonable thing to do. And I also think for myself and probably the other members that after we wrote the initial report that we now have even more information that we would like to put forward. Thank you.
Carrie?
Sure, thank you. I would like to participate as a technical expert. I'm not sure if I'll be participating or not. Just see how things go. Can I just leave it at that?
Absolutely.
Okay, from a
Tony.
professional standpoint, I may not be participating. From a personal technical advisor standpoint, I would like to be there.
And I think that from the committee's perspective, people were selected not because of their institutions or their professional affiliations. You can even see with Marian, she was with UC before, and she's with a different entity now, but it's because of Marian's background and expertise and capability that, you know, she's done a terrific job on the committee. Didn't matter where she was in terms of affiliation. So I think we would very much want your engagement.
Yeah, and it's definitely not something from this room. It's from previous experience of not knowing if I'll be able to participate. So we'll just see how it goes.
Okay, very good. I think, Mark, we got your feedback, which is that you would, how much you'd like to participate depended a little bit upon how the state would receive those comments. Does anything about what we've said here change what you?
Yeah, no, I just would like clarification on how the state would receive it, but I totally endorse what John said. And everyone's echo.
Yeah, well, I will take this conversation back to our staff to get some more guidance. Like I said, I can't unilaterally make those decisions right now. I would also add if there was you know, or has been dissatisfaction with how the previous recommendations that the committee provided were integrated into the targets or embraced. If there is, you know, if there was something that you all feel like was really missing or that we did not do a good job, you know, I would love to hear. I know we tried to our fullest ability to integrate all of those recommendations and all those recommended targets. But you know, if there's more that you know you can expound on that we can do better at, I really welcome it.
Matt, did you want to respond to that?
Yeah, happy to answer that. You know, this process and my EJAC process over underneath CARB. In both, we've been denied access to the basic function of a model. You guys ran a model once, assumed that it was right the first time. We've asked lots of questions throughout this process and should be able to run alternative scenarios with those models, play with the inputs, and it seems, I mean, we can't even get the state of California to allow heavily resourced, you know, reputable academic institutions to run these models under alternative circumstances to the deletion of knowledge. And so I guess natural resources and ARB want to be the sole owners of this knowledge, and they can be the sole owners of the consequences of it.
But
Yeah, I'll respond to that real quick, Lori. Yeah.
Okay.
Matt.
I was just,
Yeah, just real quick, Lori. Thanks.
Yeah.
Yeah, Matt. Whenever you want to bring some people to CARB to learn how to run our models, we're totally open to that. Like I've said in the past, our models are open source. They're available for anybody to run, along with the data as well. We can provide that. That's not a problem. And also, I'd just like to say there are 10 members of CARB here today, and we've had about 10 members of CARB here since May, every meeting since May, and I've been to every single meeting. So I guess I'm curious from you, what is the level of participation that you would like?
There's a difference between time and attendance. Adam, I've had formal resolutions in both bodies to get this body to interact with an advisory committee over at CARB that's going on 3+ years of collecting institutional knowledge about the co-benefits of different strategies. I got formal resolutions in both bodies that don't mean shit. So attending meetings apparently doesn't mean that either. It's okay. It's become clear that I'm no longer a constructive member of this process. I'll continue to criticize it from the outside.
Matt, I would just say, I
want you to know that I have been impressed, and I am honored to have been a part of the input, the scientific input that came in here. that was culturally competent and caring. I don't often see that. And so I admire the work that's been put forward here in the AB 1757 process. It does not conform to my expectations of the legislation. Listening and acting on people's information are two different things. And I really hope the recommendations of this committee bear fruit in implementation policies from these state agencies who just have a really hard time listening to the people that they owe equal protection to under the law. And we all don't die at the same time, and we all don't die at the same way. And it's directly related to the policies we're discussing in these committees. It's
Well,
ugly.
Matt, no, I want to thank you for just expressing those thoughts. I do want to say that from my perspective, you've been a very constructive member of the committee, and I hope that we did reflect a number of your input in the committee's
Very
report.
much so. Very much so in the committee's report. I've even said the scientists didn't need me there. They all got enough Sesame Street. They all know it isn't easy being green, and they all know how to care about others. It was heartening.
Well,
Thank you.
But we want your, so I personally, and I just want to express, and we don't need to spend more time, but I personally feel that the state did take our recommendations to heart in the governor's targets. I personally feel that those targets were well, frankly, they're pioneering and they're really a model for other states. And I think there's a lot there. So I think your work is reflected in that. I really don't know about the Climate Smart Land strategy, but I do welcome CLESI's thought that they could provide a table in their draft that crosswalked over to the committee's recommendations. That would be a way to see the impact of those.
Yeah.
So
and Lori, I'll defer to you. If I can wait and see. I really just don't like the feeling of we're coming up to our ultimate meetings, and there's a lot of questions about who's going to do what with all the time and effort that was put in here, because I've seen it get thrown away before.
Yes, there are many expert advisory committees or technical advisory committees, and their work we never really see much of. And I think as a committee, we determined that we didn't want to fall into that bucket. Thus far, I feel we have not fallen into that bucket, just from my perspective. But I'm going to be quiet and ask you, Laura, to say something. Your hand is up.
Yeah, I mean, apologies because I have to run in just a few minutes, but I really appreciate Matt's point. And I think, I think ultimately, really what will determine whether we've been an effective committee and whether the state is able to carry through on some of the ambitions is how these goals get implemented, as you sort of highlighted. And that's a much heavier lift than seeing our recommendations in a report or even in a scoping plan update, right? And I think it raises the question of how do we, maybe as a community rather than as a committee, try and keep the pressure on for implementation policies and programs that are going to make sense and actually see things happen on the ground, because that's where the people that Matt is talking about will know whether something mattered. And I think, that's where the climate will know whether something mattered. So anyway, I just wanted the implementation is, obviously where the rubber meets the road, and that's a much harder nut to crack. And
You're absolutely right. You're absolutely right. By the same token, the more times that the state reiterates that it is its policy or its target or its goal is reflective of what has come out, the easier it is to hold to that kind of implementation in the budgetary process, which is a critical item. And Prop 4 has now provided some of the critical funding, at least for initial stages, once those bonds are sold and the money is there, because that will provide the fuel to move some of this forward. But you're absolutely right. What I'm hearing is the committee is willing to A, hang on, CLESI, till you get back to us about, our status, and B, there's a desire to have that crosswalking table available, whether or not it goes in your final strategy or not, but at least for us to be able to see that impact and see that there is a willingness to work together as a group to provide, now that we've kind of all learned how to work together with one another, there's a willingness to provide committee input, whether you call us ex or current committee members. So I just want to make sure those three things, did I capture those correctly?
Yeah, I think that that's correct. And I will, get back to you on all the questions that I was unable to answer. I will also say, as far as a crossover table, we did do one for the targets. I had to take it out of a table format because of ADA accessibility, so it's in a Word document format, although I have a table available that I can email if anyone's interested. But it is posted on our website where we go through every committee recommendation and every target and lay out that alignment. So that was done and was posted alongside the targets back in April. So I do just want to note that that is out there.
Right, you offered to do that for the strategy too. That's all I'm saying.
Yeah. Yes, and I just wanted to make sure that it was clear that we did one for the targets as well, which reflected much of the work that this committee did early on and thinking all through last year on those targets.
And actually, I think certainly for someone like me, I'm somewhat visual. If you're willing to email around the table that didn't go into the ADA accessible, I know I would appreciate seeing that. I think other committee members might as well. Just kind of at a glance ability to see that.
Yes, I can send that around to everyone. I think I sent it around back in April, but it's obviously been quite a while. So I will send I can send all of the target documents around again to everyone.
All right, thanks. I think we're about to lose 3 committee members for today, but with your permission, we will be back in touch. You're not yet excommunicated with that. In terms of the remainder of our agenda, I think it's really difficult for us to comment on the implementation of Prop 4 relative to these targets in a kind of abstract way. But I would welcome. Thank you, Marian. I would welcome any thoughts if anybody is in a position to think about that or to broaden our conversation with that. We can, or we could wait until we actually see what comes out in the Climate Smart Land Strategy. One question I have for CNRA is you have a lot of implementing agencies that work on these issues. How does the Climate Smart Land Strategy influence their decision process on implementation?
That's a great question. I am going to answer off the cuff, and then it's something that I would maybe need to think about and think through each of the implementing agencies. The Climate Smart Land Strategy is not a regulatory strategy. It's not a regulation per se. So it's not, regulating another state agency to do something. It, however, has, I think, the opportunity to be built into program guidelines, to state management plans, for state landowning or land management agencies such as state parks or Fish and Wildlife. I think it also has the ability to be built into grant programs where various entities are funding local governments or tribes or nonprofits or others, private landowners, to do implementing work through various practices or activities that we may want to see prioritized. I think it may, those are probably the main pieces that come to mind. I think it can also highlight some and bring to light information on various barriers that we may have that are, outside of perhaps funding or direct land management. So scientific or data barriers or regulatory barriers where he could give us a hook to perhaps ask for money in a future budget year or work with an external partner to help fill some of the data gaps or think creatively about how we might improve regulatory processes. So those are just some ideas kind of off the cuff. I'm hoping that's kind of getting at what you're asking, or am I totally off base?
That is getting at where my question was, because that ties directly to this question of actual implementation. So that is helpful. Are other committee members, do you have thoughts with regard to that? Okay. All right. A couple of the things that I just wanted to highlight out of the committee's work that to me really speak here, and so I don't know how this will come out in the smart land strategy, but it is the nexus of short and long-term actions, which is that we don't just do something as a restoration practice and then we walk away from that, assuming that its benefit will endure, but that we link our restoration investments with our conservation investments. I think there was some really good information today and in other conversations about how to target really strategic areas where we want climate benefits to occur. Whether those are, around agricultural lands where there's riparian restoration to be done that's going to flow through and up into watersheds, or connectivity corridors where this is for species movement, but it is also native habitat and it is climate resilient, or what we were learning today from Yufeng about the ability to potentially be modeling out where those investments need to happen in the near term versus the medium versus the long term with climate change. And so there's a real blueprint there for how you tie actions together. And so that would be, from the point of view of bond funding, one extraordinarily important goal that I would put in front of the committee is not to just do one-off funding. Because we're just not in a time where it's one and done in terms of both building in climate resilience and ensuring that that landscape is there to continue to provide those climate-related functions. So that to me is one element out of, if you want, the point here was to tie to the relationship of the committee recommendations and the bond funding, which is now a reality. Those will be sold. Those bonds will be sold. I think that's the kind of feedback that when we get to the climate smart land strategy, or if we want to make a clear nexus between the work the committee has done, various state strategies and plans, and implementation, that's the kind of, we need to comb through and really target those things that we think will have the most impact. So that's a thought I would share on my end. I can see Melissa's nodding her head, but I don't know if it's to this or to something that's on her screen. Okay. Sorry. That's the downside of Zoom.
It is the downside of Zoom. No, I agree, Lori. Thanks for those perspectives. That's great.
Lori, this is Will. I totally agree. And I hope the state, and I think they do know, that once you implement these processes, they have to be sort of babied for indefinitely. And so, but my other question is, how does this effort, how do you integrate with the other resource agencies to pull this off?
Great
How do you,
question.
so Sigma is this gorilla in the room, for example, that could just totally upend any agricultural activities or efforts that we do. So how do you interface with those agencies to ensure that the implementation goals and targets and scoping targets are met or at least acknowledged into the future?
Yeah, so all of our strategies go through extensive interagency review and input. That's part of why they take so long to come out. And so DWR staff is reviewed and weighed in on and given, you know, edits to various drafts. Same with the water board through CalPA. So we do work with partners across the interagency. CAL FIRE is another great example. But you know, and I think in some respect we're kind of, a lot of these issues are new and we're still figuring it out. And how do we meet all of these really important goals, addressing all of the different crises we have in California, you know, climate crises, diversity crises, housing crises, energy crises, the list goes on. And we have a lot of big goals and big efforts, and it's on us to coordinate those. And we're working on that. You know, I think Virginia has her hand raised if she wants to speak more specifically about Sigma and the agricultural piece of this. I'll defer to her.
And don't
Yeah,
forget that hybrid agriculture, Virginia.
Well, yeah, and I just want to reiterate what Klesi said. Like, this was a really extensive interagency process. It involved a lot of time spent meeting with other agencies and explaining to them what this legislation was, and what we were hoping to do with them. You know, they all have different influences on the land base. And so anyway, enough said about that. On the cover cropping and Sigma implementation specifically, we are in constant communication with the DWR about how Sigma implementation is going, and the concerns that we have that healthy soils practices will be lost in the shuffle. We worked on and sponsored a study and a white paper by Sustainable Conservation so that they could get to the bottom of, and I would say the research is ongoing, the water budget that it takes to grow a cover crop. And then the next step is to communicate that to the GSAs, and the GSAs are interested in soil management and soil health. And so it's an ongoing discussion, but yeah, we have regular interagency meetings on this topic.
So Virginia, I think that there's some evidence showing that having a cover crop increases your net water budget also because of the, you're nodding your head. So if you've seen it, that's great. If you haven't, I can look for it and send it to you. So it's in the peer review.
Yeah, absolutely. And so it's like thinking about trade-offs. Like, we have air quality concerns as well as groundwater concerns. And so is cover cropping an example of something that is, you know, could mitigate the air quality concern. So I will find our sustainable conservation paper and stick that in the chat so that we have it.
One last for me.
Will, please go ahead.
And maybe this has been answered, maybe I just skipped over me. So how is the social equity, or how is equity going to be integrated into the implementation plan? So small landowners versus large landowners. Just the equity portion of it. How's that? And we're doing the science and you know, we did try to address through Matt and stuff like that. But I just wondered what the framework would be to be sure that when these implementations go into effect, that there's not going to be some sort of social impacts.
Yeah, just quick clarification on this. Do you mean implementation of Sigma or implementation of bond
Of this, of the.
of the targets
Right.
themselves? Okay. So I think that it will be specific program by program, and different programs have different requirements for specific funding targets and different analyses. And specifically to the bond as an implementation vehicle, I believe there's language in the bond itself about various analyses and funding targets that need to be met. There are a number of programs that CNRA has stood up or we're working to improve in order to ensure that any kind of implementation of these targets is done so in an equitable manner. One big program that we've stood up in the past year is our Tribal Nature-Based Solutions Program, which distributed about between $105 and $110 million for tribally led nature-based solutions, ancestral land return, co-management, and tribal access. So that is a big focus of the implementation for us at the Resources Agency. We are also working on developing an environmental justice strategy for the agency, and many of our departments and conservancies and commissions who either do the dispersal of the funds themselves, or they have a role in the regulatory approval of some of these projects, have their own environmental justice and equity policies that they've integrated and passed over the past couple of years. So projects will be adhering to those as well. Does that get some of your?
I didn't see the link quite. Thank you for explaining.
Carrie, did you have your hand up?
I have a question related to data acquisition and needs from the ARB, but I want to, if yours is still on the same topic, I can hold my question.
Well, it's a little bit on the same topic. I mean, I guess it's thinking about this climate smart solutions thing. I mean, we have to be thinking about implementation as a big team effort. And of course, your state agencies and you're thinking about state budgets. But one of the things that I found lacking out of the last nature-based solutions document was any sort of indication or pointers towards how other organizations could actually be working towards the same ends. I mean, the document speaks to federal partnerships and county partnerships, but just all up and down on these ecosystems. You can point to these strategies and point to NGOs, land trusts, county planning implementation that all have an impact on how well the state succeeds at this. And it seems prudent for the state to at least point them out at some level, because you have a limited capacity to tell a county what to do. But this is a document, these are things that counties should be paying attention to. And I bet unless you ask them to, they won't.
Yeah, I'll jump in there. So, with the targets document, that was about setting the ambition, not necessarily outlining every policy mechanism that needs to be put into place to get there. That's the work that is going to happen now and is already beginning, thinking about creative policy mechanisms to put into place to get this level of action happening. And that's not going to just like you said, and like we've talked about, it's not going to just be state and federal funding, because we need to mobilize more funds, private funds, other actors to get involved, because also the targets include everybody in the state, right? Not just folks that are doing work at the state. And then I would also say from a data standpoint, so we're all working on improving the inventory right now, which the idea is now that it will help counties and more local level entities to be able to incorporate national working lands into their planning, into their climate action plans and things like that. Because there are a lot of counties air districts, local planning authorities that have come to us and, they're struggling to build that into their planning because they don't have an inventory. So inventories are hard. And so we're hoping to build that into our inventory so that we can facilitate that for the rest of the state, different jurisdictions.
The other thing I'd add to that is, in addition to trying to, help with the data gaps that the local governments need in order to build the stuff into their climate action plans, is how we can scale and improve capacity building and technical assistance. I know that the Department of Food and Agriculture has done a ton in this space. And if Virginia wants to speak to that, I will let her speak to kind of the building of a TA. Like it's almost larger than a program now at CDFA. It's kind of a way of doing work. But that's really expanding across the administration, is how do we as a state invest in capacity building, invest in TA skills building. Workforce development is another big piece here that we have engaged the Workforce Development Board, Labor and Workforce Agency about, how can they be involved? How can we build these career pathways? And I think we've got a really interesting opportunity through California Jobs First, which is an economic development program that the state is managing, where local regions are, creatively visioning what their economic future looks like in a post-fossil fuel world. And we're, working with them where they're interested, and we can, to help them build nature-based solutions into that future. And what does a nature-based solutions workforce look like? And how do we make sure that these jobs are, family sustaining, high wage jobs that are going to be around into the future? Virginia, I don't know if you wanted to add specifically on some of CDFA's work there.
Yeah, sure. So for the past few years, we've been working on the development of a technical assistance network. We have an MOU with our California Association of Resource Conservation Districts, UC Ag and Natural Resources, and the Natural Resources Conservation Service. And this is all in recognition of the key role that technical assistance plays in getting adoption of climate smart land management practices. And so how can we make sure we're streamlining our services, referring our people to each other, pooling resources that we have, developing materials that we can share, like building those educational pipelines like Klesi mentioned. It's just a whole ecosystem of providers that needs to be stood up, and it's a high priority for us.
We got a thumbs up from Matt. Go.
Okay, awesome. Thanks, Matt. Or maybe that was for Virginia. Anyway, earlier I got a little emotional. I'm back together again. But I wanted to ask you about, so several scientists I know have been canvassed or received emails asking us for data. And I think there might need to be potentially maybe more explanation as to what you want, like what kind of carrots there are for us, a public database of data that's been collected that we could use in the future, because it's a pretty big ask for us to give you curated data. The other thing is that we often post our stuff anyway, just as feedback to open databases already, where we can get a DOI, and we use that for to document our work, to reference it in our future work, and then also just, for promotion, it lets us do the bean counting we need to do. That sounds so terrible. But anyway, so I was just kind of bringing it up because I think that we really want to, I know that the scientists that work in agriculture, we do really want to connect the science and policy and provide information that allows people to make decisions, but it's Yeah, there's certainly a tension there in terms of how much time we can spend curating good data for you. So just throwing it out there that that would be great to have an additional, like more conversation. I can't remember the name of the person who contacted me. You okay? So yeah, so I haven't figured out here. And also it looks to me that like your guys are still using DASEN. Is that because it looks like the questions I was being asked were very, or maybe you're making something similar to that, a practice-based approach. Is that what you're doing for your work?
Yeah, we're currently building a new model that will be open source now and free to use as opposed to DASEN. And then also driven by remote sensing data as well. And actually, and more tailored to landscape level assessments. So for inventories as opposed to like farm scale. So it'll be like a more simplified model than DASEN or DNGC, so that we don't have to drive it with so many parameters that we can't necessarily get across the whole entire state, and hopefully also constrain it with remote sensing. Kind of like what Yufeng was talking about, where it's the process-based model and remote sensing hybrid.
Okay.
Yeah.
Makes sense. Thank you.
Yeah, we'd like to hear feedback about how to make this data gathering mutually beneficial for everybody.
Sure.
You know, one of the other things, Adam, that would be, I think, wonderful for us to hear your thinking about is the relationship between the scoping plan update and these targets from the governor and the climate smart land strategy. Because so much of the rubber, shall we say, meets the road, or maybe we should be saying so much of the carbon meets the sequestration as a result of ARB scoping plan. So could you share some thinking about that?
I could tell you what I'm thinking right now, but there's still a lot of time between now and 2027. So with the last scoping plan, the question was really like, what level of activity do we need to make a difference, and how much will it cost, and how much will it affect public health, and all of these things. And so now with the nature-based strategy or nature-based solution targets, the level of action is set, right? So now we don't have to go back and do that sort of analysis. So now the question is more like, how do we make that information more applicable to local level implementers? So maybe thinking about different ways to, distribute that work across the state in different ways. That could be potential one way to go about it. I mean, we'd like to hear more information actually from folks on the ground, implementers, local level planning people, environmental justice advocates about what they see as actually something that we provide with the next scoping plan as well, so that we're not just sort of thinking, oh, this will be helpful. We would like to actually hear about it beforehand. So people have ideas about what the state could provide that will actually be useful for implementing on the ground, broken to ideas.
Mm-hmm. So I heard you say something, I just want to make sure I'm hearing you correctly, is that in the scoping plan, you set the targets, you evaluate the costs, you identify the benefits, co-benefits. So the targets are set because those have come out from the governor, but the costs and benefits also now will go into that update, correct?
Oh yeah, that's actually legally a part of the scoping plan.
Right.
Yeah.
And
but we could adjust those costs and benefits depending on how we distribute the work across the state, right? So yeah, that would be a part of the question.
This is just a thought which I have no idea if any committee members are interested in it or not, but if you want input from different members' experience on costs and benefits, I mean, some of those are costs are not necessarily identified, but certainly benefits are identified in what the committee provided. But it's helpful to know, and Matt, that's something I think where I would feel good about is Adam saying, now that work has been largely taken care of. The target setting work is largely taken care of because of the work of the committee. So it is a very direct reflection with a lot of input from the agencies and so on and others in that process. But it seems to me that that is a very direct reflection of the input of the committee. I've left him speechless. I'm sorry, Matt. I'm teasing. But where it comes to cost and so on, because I think that you have quite a few people here who have done the work on some level of some of these implementation, whether it's Devi and her approach of knowing what cost share will achieve or not achieve, or Melissa and her work in wetlands, and John. So to the degree that we can be helpful in providing input on the question of costs, in addition to what we've put down for benefits, I suspect people would be willing to help.
Yeah, well, when we get there, we'll come knocking.
I know you got to work in 2026 to get there in 2027. At any rate, although I mean, it's very impressive to see the staffing up that you've done, but you know, it is a partnership effort from the two of you, agencies, both agencies of ARB out of Cali, PA, and CNRA. Are there other thoughts from committee members at this juncture? I know we have Bonnie, who has been very patiently sitting in the viewing room. I don't know, Bonnie, if you have any thoughts you wanted to share at this juncture, because I think we are moving towards a wrap up. So this would be external comments on the committee's discussion at this point.
That is okay. Thank you so much for the opportunity.
Well, unless there are other comments or questions, and thank you, members of the administration, for being engaged and transparent in your responses. We may want to move to the last item of the agenda, which is any other business? Summing up and appreciation. Going once.
Can I make one comment?
Yes.
I have a comment, and I think it's just because of having worked in the agricultural space previous to this, and also Willa works in the space where we're looking at ways to practices that minimize nitrous oxide emissions, and knowing that it has such a large global warming potential, that particular emissions, and that we have been coming up with methods in the field that could reduce those emissions yet still meet the yield potential of the crop. So I'm wondering, because this is a very carbon focused exercise, could you tell us how you're planning to incorporate nitrous oxide into this next phase?
So nitrous oxide, well, yeah, N2O has always been included actually in CARB's climate strategy. Actually, that's the one gas that has always been included in all croplands. So even longer than soil organic carbon, for example. So yeah, like the model that we're building now, that's a process-based model, and it will focus on soil organic carbon, N2O, and methane.
Okay, and it'll explicitly call out, like, so we'll have a section for fertilizer applications. I mean, will you be able to deal with these new?
I don't know about like fertigation or whatever, but
based on fertigation, can you deal with that?
I guess I just want you to be aware that if nitrous oxide isn't accounted for, it could be, again, the gorilla in the room, and that any management you do to offset emissions could be just offset by a little bit of nitrous oxide emissions. And these nature-based solutions, if they're not managed correctly or implemented correctly, can actually increase nitrous oxide emissions. So you have to be very careful.
Yeah, we are aware, especially in annual croplands. N2O is really the heavy hitter in terms of climate impacts. So yes, we are aware of that, but it's always good to be reminded.
Yeah, that's okay.
Well, and since we're going to talk about this, let's take note of the fact that there's been a great publication on how bacteria in trees, in the bark, eat methane. And the larger and older the tree, the more methane they eat. So that is a twofer as you are looking at your calculations on the benefits of having older, more natural forests they eat methane. That's pretty cool. We didn't bring that up in the report because that had not been published at the time of the report, but it has now.
And also, because the nature-based solutions can actually increase methane consumption in upland soils. So, you know, something else to think about.
Yeah.
All right. Well,
We got a public comment.
Hi, Lori. This is Brian Show with CalCan. I'm going to maybe segue us to gratitude with a comment on next steps. First, I just want to reiterate the thanks to all of you on the agency side for all the work that you've done on the targets and the forthcoming strategy, and also for all the advisory committee members for all the input the last year and a half. And in thinking about next steps, I just wanted to kind of note for the advisory committee members who maybe are thinking about input on the strategy side going forward that there are certain recommendations that the state agency staff can act on, especially as it relates to interagency coordination, modeling, data, et cetera. In some cases, regulatory reform, and some recommendations, especially as they relate to legislation or funding, are things that state agency staff have sort of a more difficult time leading, have constraints on what they can advocate for. And so I think, to Lori's comments earlier about ongoing funding, I'm pretty confident I can say most of the state agency staff would love to see ongoing funding for the programs we talk about here, but they can't actually advocate for that. That's where advocates come in and the legislature comes in. And so just as you think about where to direct your sort of recommendations, important to think too about the role that advocates will need to play in the legislature in the year or years ahead. And as one example of that, we just passed the bond that came through advocacy and legislation. And next year, we're hearing the legislature is likely going to revisit cap and trade and the continuous appropriations from that source of revenue. That's another place for us to be looking to fund some of this work. But that's something that agency staff are going to have a difficult time advocating for directly. So just wanted to acknowledge those constraints and help direct the right recommendations to the right audience.
Yeah, we have another public comment.
Yeah, but I just want to respond there. I just want to say thank you so much because it's definitely a three-legged stool, if you will. The advocacy community plays an enormous role in pushing things forward, and having the opportunity to interact through this time and with the subgroups that we had with our ad hoc working groups, our non-official ad hoc, occasionally constituted working groups. I know that many of us really appreciated the opportunity to work with you guys. So thank you for that, and it's a really good reminder. So I know we have Brian on Zoom. Is there anybody else in the room that wanted to make a public comment?
Yes, it's Brian. He's in the room and on Zoom.
Oh, okay. Brian?
So regarding those targets in 22 scoping plan, 7 million tons by 2030, right? Where it can be captured, like that. We're making proposals to the California Energy Commission using direct air capture with enhanced nature-based concepts, where we can beat the governor's targets, and so using again carbon enrichment technology. Okay, so it's been proven by USDA for 40 years, and we have come up with a much cheaper way of doing it, and actually piloted through as maybe Virginia, James, you may know, Pierre Ross and OEFI have awarded us a OEFI sweep grant to pilot this technology. So keep up the good work. We're grateful for your targets. They are achievable. Let us innovators do it for you.
Can
ask a follow-up question to? Is this the work of Long and Ainsworth?
Long and Ainsworth is with, they've done it with a Brookhaven National Laboratory technology that costs $1 million an acre. We've recently patented it where we can get it under $500 an acre. So we're doing it for they're using pure CO2. We're using clean industrial-based diluted CO2, much cheaper. But we're using a form of that technology, but in a better way. Yes, you hit it on the spot.
Any other comments from the public? The room?
I want to
Okay.
acknowledge the ARB staff for shepherding us through this process. Thank you very much.
And CNRA and CDFA.
Yeah, thanks.
It's CDFA, yeah. Everybody. You got California leading the way.
This is one place where Zoom is much better with its emojis because you can shower, little rockets, or you can send up celebratory cones and hats. But yes.
I'm pretty sure I saw those emojis just coming out of Will's head there a second.
There you go. All right. Is there any other business that anybody wishes to raise, or shall we sum up and close the meeting? Well, I know there are a few follow-on steps here. We'll be looking forward to hearing from you, Klesi, in particular. But I just want to reiterate my thanks to everybody for their participation. Everybody's been really generous with their time and their thought on all sides, both committee members and then with the agency. So, Adam, I really appreciate the fact that you have made every single meeting. It is impressive, and it's wonderful to see your staff grow and be very competent, and look forward to the opportunity to work with you all in the future. And Klesi, it's been wonderful to have you come in. Please thank Jen for her work earlier in the process. And Chelsea, even if you abandoned us, we still love you and we forgive you, and we know you're going to be doing great things in the future. So this is a close for now for our formal meetings. I don't know if there's anybody from the agency who wants to say anything further, but I just want to say thank you all, each and every one of you, for all of your input. So
Yeah, again, I do want to thank everyone. If Amanda was here, she would also want to thank you, and also Matt and everybody who put time in, and CNRA for providing the funds that we will give if you haven't gotten it already for attending the meetings. And yeah, we do appreciate, we are listening to all of the comments, and we have a lot of good side chats, which I think are also productive when people are here in person. Also, there are some committee members who have also been to every single meeting, so thank you all for the 100% attendance, A+, and everybody who could be here when you could. So yeah, thanks. And this doesn't have to necessarily, even if this is the last formal meeting, you can always reach out to us. We are available. We are public servants, so you can talk to us and give us your recommendations or have a chat whenever you want. So
Yeah, no, just echo everything Adam just said, and really just want to reiterate what I said earlier about the recommendations document that you all put together last year was incredibly helpful as we were putting the targets together. And I know you haven't seen the draft of the Climate Smart Land Strategy, but also very helpful for that draft. And I hope you can see that reflected when it is published. And I'll do everything I can, and I'll go on the record saying it, that I will try to put together some kind of comparison. And again, you can always call me and ask me, where did this go? Where did this go? And we can get into the weeds. It's been really an honor to get to learn from all of the guest speakers. I don't think any of them are on the line anymore, but really appreciate you all, introducing us to their work and getting to hear from them. And I know it's been helpful in building our relationship, especially our technical work when we're getting ready to start, doing this inventory and modeling. So really appreciate all of these connections, and the productive relationships that they have built. And if we can improve, please let us know. I really meant what I said earlier about, making sure this is like a good process and you can see how your work is reflected.
All right. Well, everybody, we are sending you out with 18 minutes to spare. So I hope you use it wisely and that everybody realizes just what an extraordinary state California is for climate action, particularly as we're looking at what we're looking at for the next 4 years. The model that we set here is one that will shine through an awful lot of hot air. So with that slightly partisan comment, but it's only slightly partisan, thank you all and take care.
Thank you.
Thanks, Lauren.